Mic check, mic check. There we go. Good on that. We'll be live in a second here, lads. There we go. Good on that. We'll be live in a second here, lads.
All right.
Yep.
Is it going to click the live?
Yeah, it's going to reset everything.
I love the name. Not a globe, says Mountaintop.
Cat came up with it.
Oh yeah, I got an update today on the Lake Pontchartrain Bridge build plans. So basically the DOTD, the Department of Transport Development, was supposed to be the ones that had the paperwork and the documents on like the final build plans, but they said that they didn't, and so I have to read out to the Causeway. Basically they have like their own like department and like the Greater New Orleans something, whatever. Anyway, so then I reached out to them today and the engineers. But yeah, it's really hard to get these build plans. So whoever said, "Oh yeah, it was had curvature in the build plans," like I highly doubt they went through all this rigmarole in order to get them. But I'm working on it.
Told you. It's crazy, right?
Yeah.
Are you supposed to be able to have public access to stuff like that?
Yeah, you should be able to. It's like a state, whatever. It's built by the government and they should have access and documents where you can get the information. You're supposed to be able to reach out to the DOTD and get them, but for some reason they don't have them. So, trying to move on from there. I sent another email today. So
They only keep records of the financial.
trying to move on from there. I sent another email today. So
They only keep records of the financial.
Have you hosted before, Taylor?
no.
Oh, I was going to ask you if you've seen that option because I haven't seen
It's
it on
not
there.
on iOS.
Oh,
Yeah. I'm assuming you'd have to open the Twitter space on the phone with the option, with the video option, then you could just kind of function from there. And you have an option to turn your camera on and off. This will be really helpful in showing people stuff and demonstrating stuff like during the spaces.
Hello?
that is up.
Okay.
Yeah, we can hear you now, and you're streaming the audio from Discord.
Nice. It automatically reconnected. Cool. Well, okay. Well, hopefully that works out then. So we got everything there. Let me try and go live on YouTube.
Do you intend to stream the whole Discord to TikTok as like a battle room of people to help that we can just?
No.
Or is that not intentional?
No, not well. The audio coming through, but that's because I wasn't muted.
No, it's it's coming through because of.
Yeah, I didn't realize. Yeah, I didn't realize it would reconnect or whatever. So anyway.
Hey, Katie, what's up, Katie? Tell the squad we live.
Yep.
Told you we was coming over here.
What is that noise? Oh, that's TikTok.
I see Indio in here. I see Shane. I see Galatrax. Dizzy Dents. Bossy Cat.
All right, there we go. Had some audio issues. So it turns out I can't stream on YouTube while doing this right now. So anyway. Yep. Let's see. Co-host. All right. Are you in the stream, Shane? On your phone? All right. I don't see you on there. How do I invite you, lad? Yeah. Oh, wait. Yeah, multi-guest. Here we go. Taylor, accept. Liliana. Oh, how do I open it up to people to request?
Be able to open up your camera, I don't think.
No, I have OBS on. I have fake camera on. There you go. Yeah, you can show your camera,
Look.
Shane.
Yeah, you there? So, all right. So I could do I could do database.
Show your camera,
Look.
Shane.
Yeah, you there? So all right. So I could do I could do database sharing if we needed.
Yep.
All right, that's cool.
And I
That's
can
cool.
I
That's
can
a really
also
gay way to do it.
well no I can also just screen share
But
for
it's
you.
good to know.
Can you hear me, Shane?
Wait, how
Yo,
are you doing?
can you
TikTok
hear me
your
on
desktop?
Can you hear me on TikTok, Shane?
Yeah. Well, yeah. Wait, hold on, wait.
How are you streaming your desktop?
Co-deafened again?
Testing. Can you hear me?
There, can I hear
Shane?
you on here? No, I cannot.
Yeah.
Wait, yes I can. I'm good.
Okay. All right. Cool. So yeah, I can screen share for you because of the way that we have it set up.
Nice. That's way better. Yeah.
All right.
Alan,
Cool.
if you need another mic, you can have mine whenever.
Thanks, Lily. Shout out to the ambassadress of Flat Earth. What's up, Sacred? Welcome.
Good to be here, Alan. Shout out to Space Audits. TikTok, we here. You told you we was coming. We in here. What up?
What did you title it?
What'd you say, Taylor?
What did you title the space?
The title is Not a Globe, Says Mountaintop.
Perfect.
It's a pretty good title, you think, Taylor?
Yeah, remember it's
Pretty good.
trigger off the Glovers to come in here.
It's super relevant because Hasselblad and I are otherwise known as, what was his name? I can't remember.
Josh.
Yes.
Josh.
Was discussing shadow sets with me. And he tried to make some non-analogous arguments and assertions about perspective and how it wouldn't work, and gave some non-analogous scenario. And I was waiting to, properly document and lay everything out and get some other resources, which were provided to me. Shout out to Sacred and Gleam. And now we're going to go over shadow sets to completion here. And if anyone would like to, find your nearest globularist proponent that says that this is a mutually exclusive proof of a globe, we would love to have them up as we discuss this and go over it. Welcome, Kat.
Real quick before you start, Alan, everyone in the live, sorry, I got a little bit of feedback. I'm going to try to fix that. Please double tap and share it with everybody and your friends. Just let them know that we in here.
Sir, let everyone know. All right. All right, so shall I begin, gentlemen?
Yes, please, sir. Begin.
All right. All right, so we're going to start off with following the logic of the old null hypothesis here, right? Starting with using the objects in the sky to prove the shape of the ground. You can't use it to prove what the shape is, but you can show what the shape isn't through going over mutually exclusive evidence and finding out if the geometric properties of a sphere are interacting with the celestial bodies in such a way that mutually exclusive geometric outcomes have to occur, and a couple other references that are external to positions of the celestial bodies to determine curvature. But what we're going to focus on today specifically are the geometric properties of a shadow at sunset that would have to occur. So we've all been told that, hey, when the sun is setting, that's only due to the Earth being a globe, and we have some diagrams of that here. So this is kind of what they're putting forward, right? If the Earth is a globe, then this is what we would be looking at in terms of what's causing the shadow. So there's a big component to this argument, and it's not just that there will be a shadow casted upwards on the top of a mountain. When you're standing on the peak of the mountain, you would see this upward shadow. That's one part of the argument, but the other part is that there will be a curved shadow that sweeps across the sky, and also corresponding shadows on the ground will exceed the height of the objects casting them. So we're going to go over all of these evidences and examine the logic behind this being a mutually exclusive proof of the globe, because as it's going to turn out, this is going to be direct evidence against the globe. So here we go, following simple modus tollens. If P, then Q, not Q, therefore P. Right? So if the Earth were a globe, then a sunset must be lower than the physical horizon, and therefore the Earth is not a globe, because we're going to go over what these geometric properties are going to look like. Because what's presented in the mainstream is this narrative that this observation right here proves that we live on a globe. Now, I'm going to show a flat Earth equivalence here, but also there is a lack of defining characteristics to this whole thing, which shows that the evidence is actually towards one side of the equation here. And that's going to be towards the Earth being a plane and the sun never going below the horizon, which again would be the distinguishing feature of a globe, casting a shadow due to its curvature. So this upward casted shadow here, it looks like it's, casted at an angle, looks like it's going upwards. It looks like exactly what the globe would predict, right? But this is just due to perspective, and we're going to show that. Now, remember though, in addition to this shadow being cast, there's also a dark band that has to go across the sky at 15 degrees per hour as the Earth rotates away from it. That would have to be in addition to this shadow here. So again, here's some more pictures of that, just to kind of reiterate what's put forward in the mainstream here. And here we have a video from Globe Guy McGloberson, who ends on saying, the long triangular shadow cast by the sun on the mountain on the bottom of the clouds is only possible on a globe. And globe perspective and word salad and things like that were said by Hassel last night. Now, remember, if anyone wants to tag these people and invite them in to have an actual conversation where they're not going to be able to scream and yell the whole time, that would be great, because they should have a chance to say their piece, as they were so boldly claiming yesterday that they were here to correct misinformation. Well, if that were true, then we could discuss the particulars of the situation and the observations on the merit of them, now that we have them all presented in order. So that would be awesome if they could come through. So again, here we're looking at this shadow, and oh, look at that. It looks like it's curving up. Must be a globe, right? Well, no, that's just perspective. When it's sunset or sunrise, you get this same effect where this shadow converges to the horizon on the top of clouds. Now, what would have to happen if the Earth were actually a globe and the shadow were being cast like this upward at an angle? 1 second. There would have to be when you get on top of here, you would also have to see a shadow cast up into the sky like this. But that's not what happens. It's always like this. It doesn't matter if it's sunset or sunrise. This is the same effect. Now, in addition to there being a lack of a a sharp, distinct curve shadow going across the land, across the sky, and underneath clouds and all of that, this goes on either side of how you're looking at it. The sun is never above, and we're going to see, or I'm sorry, the sun is never below the horizon, and we're going to see a physical demonstration of this analogous to how it would play out on a flat Earth. Now, again, real quick, another important component to understand how we see is the geometry of how we see. And we see in what's called curved visual space. Now we have our 180 degree field of view right here. And a lot of people think that, that's where our field of view stops, but that's not true. It actually makes a complete circle around us. And there's some ways that you can kind of figure that out. One of them would be corpuscular and anti-corpuscular rays for divergent sun rays. And when you see those, they make us, they literally wrap around you. And this is just a natural effect of optics and how you perceive the sky in particular, where the effects are the most pronounced. Now, oh, absolutely, Taylor. Anytime
What do
you
you
have a
mean
question.
they wrap around you?
So when you're looking up above, like this shadow, for example, right? Instead of a sunbeam, we're just replacing it with a shadow because they're analogous in this, or they're the same in this scenario. Same effect is going to happen. So you see how this shadow starts out converged here off of this point, and then it diverges out.
Yep.
Okay, so if you were looking up, you would see the maximum width of this shadow up at your zenith, looking directly 90 degrees up.
Okay.
Does that make sense? And then if you were to turn around, you would start to see it converge behind you back to a point at the horizon. So it literally makes a dome and arc over you just from your perspective.
So is the shadow, like if we were to have like lux meters up there testing sunlight, is it a real shadow or is it just from perspective?
No, the shadow is a real effect. Like that's the absence of light there. But how you're perceiving it in relation to the other illuminated parts around it is what's creating that curve, that divergence and convergence around you.
I see. Okay.
Great question, Taylor. And yeah, so that's what creates the azimuthal grid of vision that we talk about. That's what the Royal Society in the 1800s pioneered for optics, for how they were going to, map out stars and stuff. So anyway, this is how we view things optically. This is creating that same effect. The sun is not below that cloud, right? This is just an optical effect here. So we're seeing the exact same thing with power lines, right? They're not really getting smaller down there. They're not really getting bigger as they get closer, right? They're always the same size. This is just an effect of perspective. And to say that, this isn't a real phenomenon or this isn't analogous to how we perceive things is completely disingenuous.
Dude, the only distinction they make is when we measure stuff with known heights and trigonometry, they just account for all that is missing without accrediting proper things like angular resolution, atmospheric opacity, light attenuation, things that are regularly known and measurable, metriced out and empirically known. They just avoid all that and they say, look at all the curvature we found based on the missing height on the known height from the trigonometric function. So it's good to know that, yeah, this is definitely a known aspect of perspective. They use it for curvature all the time.
Exactly. That's why when dudes like, so do we see in globe vision? Yeah, the globe was derived from your optics, bro. Like there's no shame in that. You're not going to socially shame it out of me once you know that there's a radius of vision for your dome.
Oh yeah, to be clear though, you know how the other guy went right to space the other time?
Oh yeah.
Yeah, it specifically doesn't apply anywhere near not ground level because you're literally equating what is like a parabolic information loss with a linear information loss because like my like projection of it would be a linear information loss based on that linear loss that you're seeing right there in front of you. So it'd be an actual linear loss, but the whole point is under 100 miles, they're identical. Right? That's why we can use the parabolic formula 8 inches mile squared for the same approximation of the circle over short distances, specifically because of that overlap. So when everything we're talking about only overlaps at ground level for the intersection of those two projections of perspective and nothing, as soon as you've raised the observer level to thousands of feet, it goes out the window. So.
Yeah. Nice. So another non-analogous use to build the case for the globe.
Yeah, they immediately invalidated the argument by making it retarded and then strawmanning it so they could beat it up. Just want to clear that up because the proper way is it only applies at ground level, which is where we started and kept wanting to talk about. But I don't think that we said that.
Well, unlucky. So here we are continuing off of perspective, a little bit how we're perceiving these shadows. So again, just to reiterate, in addition to, a shadow being cast by a mountaintop, right? In addition to that, there has to be this hard cutoff shadow that's going to be distinct from all other shadows that will be cast under clouds as the Earth rotates away from the sun. And that's not what's present. And the other component to this argument is the specific properties of shadows on the ground or high-rise buildings, etc., that are facing west at sunset, especially if you're at the beach. You would have objects casting shadows higher than the objects themselves. So here we have an example of two pillars that are shaded out. They're casting shadows that are higher than the pillars. This window is casting a shadow higher than the window itself. And on a flat Earth, what would happen is the shadows would never exceed the height of the object casting it. And the shadow would actually slow down as it climbs up the wall, and then it would just fade out as the sun leaves. And based off of it taking taking the daylight with it, the excitation of noble gases with respect to the sun's magnetic field as it traverses over the tropics, because the sun has a GP, a ground position, right? So as that position gets further away, it has a magnetic field with a radius around it. The excitation of the noble gases in the atmosphere start to die down, and that's what changes the colors to create the belt of Venus. What we're going to see, let's see. Oh, Shane St. Pierre got violated for hate speech. I have to remove you from the thing. Wait.
Saying what?
Oh, wait, no, I don't have to remove you. It's warning me.
You should probably drop him and bring him back up. I ain't gonna lie.
Okay. Let's see.
You
Disconnect.
should probably give all your mods those permissions as well, but we'll get to that after.
Okay, cool. So bring Shane back up. Okay. So anyway, we're going to go over the rest of shadow sets and then the belt of Venus, which was presented once as the Earth curvature shadow that we're all looking for here. So anyway, you're unmuted, Shane, by the way. So we can hear you moving your mic. So here we have a shadow cast by a window at sunset, and it never exceeds the height of the window. Over time, the shadow increases up a little bit, and then it stops and stays here, and then it fades out as the sun sets. Now you can watch the complete video for that on my YouTube channel, and I have a link here for what is this? I think this is the simulation. So also we have it modeled out here to scale by an engineer on Taboo Conspiracy's video. So if you guys want to see, this whole thing modeled out, you could watch this here with how it plays out. This is all perspective wise. When it was stated yesterday that no one has ever done this, there's no videos like this exist on the internet, never seen them before, etc. Well, it's been here for a year. So anyway, here's a topographical / orthogonal view here of what we're looking at. Now, again, remember, this shadow would have to be casted up into the sky if the sun was, physically below the horizon casting this shadow. Otherwise, this would just be a factor of perspective, irrespective of the time of day. The time of day being different is a non sequitur to the argument. Well, for them anyway, but it's completely relevant in the fact that at either time of day, the shadow would have to be going upwards in reality and not cast downwards relative to your position. When you're at this apex of this mountain here, the shadow should still be going up, but it's not. So anyway, here's a side view of the sun casting the shadow down on the clouds, what we're seeing, and the same effect. So when you're down here, you're looking up, you're seeing the same thing. Again, the sun gets further away, the angle increases, you see further out for the shadow. Same exact thing. Now, on a globe, remember, the sun is going to be physically below this obstruction here, so the shadow is going to be cast up into the clouds, and that's never seen, especially with that hard shadow that has to come through. So here's an example of what that hard shadow would look like. Sometimes they'll call it the belt of Venus, but what we can go over here. Oh, I didn't add that. 1 second. That is from here. Remind me to come back to Belt of Venus. It's didn't add the slides to that. But anyway, basically you can take a high altitude weather balloon and look at footage from the sun, you know, as it's further away past the terminator line, and you could see that it's still in the sky, and you could see the distinguishing features of the magnetic field. Like it's not being, this isn't caused by physical obstruction of the ground. This is caused by, you know, more likely the excitation of the magnetic field of the sun as it moves away with respect to the excitation of the gases, because the sun's still above the horizon. You can see it in the video. I'll play it at the end here, but I want to continue on to this demonstration, the physical demonstration, which is very important because yesterday Hasselblad was trying to say that, you know, I have a light source here, I have a birdhouse here. How do I make this analogous? And I told him to put a sheet of paper above it, above the birdhouse or something, you know, so that the shadow could be cast on it. And he didn't do it, but he did move his camera and look up at the ceiling and was like, "There's no shadow up there." But you know, again, not analogous to the angles and stuff. And so anyway, we're gonna see what it looks like when you do this analogously here. So this guy has a garage. It's level. He has a jack. He has his flashlight level.
Real quick, Alan. I'm sorry. All you Globers in the chat right now, pay attention. Y'all been spamming globe proof head ass this whole time. Pay attention to what Alan is presenting right now. Continue, Alan.
Yes, thank you, sir. Very important to pay attention here because remember, no video like this exists. We're correcting misinformation, blah, 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 right? This is supposed to be mutually exclusive for the boys here, but as it's going to turn out, actual demonstrations shows the perspective argument that I was talking about here. So here we go. We got a jack. We got the light source leveled off. He's going to pull it away at a linear speed. So it's going to the light source is going to move away, and we're going to see what happens to the shadow from both perspectives here. So here's the light source now moved away. So now what we're looking at is from the perspective of down on the ground, what an observer would see as that light source, which remains at a constant elevation in reality, but moves away. So its apparent elevation angle changes. Sounds very similar to something moving through your dome of vision. Dude, this is like a little mini dome of vision recreation. But anyway, what we're seeing here is this shadow that the arrow is pointed to is being cast up onto the sky above, just like what was shown. So like if the cloud deck was up here, this is what you would be seeing this cast on. This is all just perspective here. Very important. So we're looking at the starting where the light source was the closest here. And then as it starts to move away, we're seeing the shadow come out, more shadow being cast. And then we see as it's the furthest away, now we're seeing the shadow doing the same thing. And remember, this started above the object. It's never been below it. It's traveling at the same elevation. There's a video of it. We can watch the video play out here in a second. But this is exactly what I was talking about. This is the analogous scenario. This is perspective. So we'll watch the video now real quick.
Wait, Alan, you telling me that garage not curved?
The garage ain't curved, bro. Oh, I wonder if let's see. Well, I don't have access to that drive. 1 second. I can pull it up on Twitter real quick. This is a very important video. And of course, I'm not signed into Twitter.
These all sound very much like Linux problems, Alan. I'm just going to say that.
Yeah, I'm on Windows right now. But I haven't signed in since I went back to Linux, so I guess it is kind of a...
Indirectly right. I'll take it.
Yeah, indirectly right. All right. Video coming up, and then we can move on. Just wanted to set the record straight and provide everyone with ample information here.
Got really quiet in the chat. All those guys saying globe proof, globe proof. I
Oh.
don't really see them really acknowledging this demo. Interesting.
Interesting. So here we go. So this does have audio to it, but you guys aren't going to be able to hear it on here, I don't think. But I'll be back in 2 minutes while this plays out.
Is he allowed to play this Sacred? Sometimes if he plays stuff on other platforms, they in the space. I'm just wondering.
Yeah, it'll be fine.
Okay, we'll see.
I don't know. Rules seem crazy.
Back. Flat and level. Not changing height to the sun, just goes away. You will see from the other angle that it goes down due to perspective. As it goes down, as the sun sets, the sunlight hits the mountain and causes the shadow up on top or on the bottom of the clouds. At that point, looky there, shows the shadow. And we'll check it out from the other angle. You can watch the whole shadow as it's formed today.
Globers, pay attention to the light source.
Today, sun's going away.
Is that an apparent elevation angle?
What?
No way. I thought those were some sort of absolute thing or whatever that's dictated by ball geometry and not perspective.
I definitely thought that was only due to curvature. Wait, so you tell me there's curvature in this picture, but I'm just not seeing it, right? And it's causing this?
I mean, you would have to argue that. Maybe we should change to like a rectilinear lens or something.
SDMP, the triangle is not taller than the box, to answer your question.
Now, as it goes away, it appears to go down because of perspective again. If I'd have kept going, it'd gone all the way down to the horizon. But see, there's the shadow upward on the bottom of the clouds. Sun never changed height, didn't move at all. Both angles uncut. V-shadow underneath the clouds because of perspective due to shadow. Looky there. At that point. The flat level plane that we live on.
Long triangular shadow cast by the sun on the mountain on the bottom of the clouds is only possible on a globe.
Yeah, someone said in the comments that the triangle is connected to the box there. It's higher than it. And I agree. I would like to see this done with it being lower than that.
But wasn't the mountain higher than the clouds in that video? Didn't we find that out? So it'd be kind of simulating that?
No, absolutely. But still, it's a good point just to make it like, analogous. He's right, though.
Is it higher than the box?
I mean, if it wasn't, you would see. I was looking through here. I couldn't tell, but it looks like it is. It's hard to say.
Well, I guess it wouldn't matter because that top of that mountain was still higher than the clouds if you looked at it from the top.
Right, but
It'd be kind of mimicking that either way.
Yeah, for sure. But still.
Bro, I could literally create a shadow on a surface above me without the object touching the surface.
No, I understand, but for continuity or whatever. But anyway. Yeah, so there we have it. We own shadow sets. We own sunsets. The argument that shadow sets, sunsets only work on a globe is dead. You don't have the corresponding shadow set. You don't have a sharp, distinct shadow that sweeps east to west as the Earth rotates away from the sun, or as the sun moves away from the Earth. Either way you want to slice it. There's no physical obstruction caused by curvature. And if any glober would like to come up here and talk about this, you are absolutely welcome to.
I was going to say, but they do like to take things that could only happen on a flat Earth with a local sun and claim it as globe evidence for a really weird reason.
Yeah. Where do I find that video? Absolutely. Here is video phase 1. Oh wait, did it cut out the full? No, you're
When
good.
you find a video, y'all need to leave TikTok to come to Twitter.
Yeah.
We gonna give y'all the sauce anyway.
Oh yeah, Twitter.
Y'all seen how young Globy looked? I mean, we done refuted this position years ago. Y'all should stop saying this.
Dude, it was crazy.
Dadbod says that he can give us absolute proof of Earth's curvature, so I would love to see Dadbod come up and do that.
Nice.
Well, the argument is what you're saying doesn't matter, even though my point is now null and refuted. But however, I still know this curvature, so I win.
Nice.
To see somebody address the shadows, which is the topic at hand.
Yeah, he's like, even though there's no shadows, I still know it's a globe. So there, that's literally the position that dude just took. That was a weird pivot.
It's a hard position.
It's cope. It's a red herring. It's like, hey, don't look over there. Look over here.
So yeah, check this out, lads. If you go to Taboo Conspiracy's YouTube channel, and shout out to Taboo Conspiracy who put all this together about over a year ago, and it's just kind of like a slept-on argument, I feel. But here's all of the links to everything that I provided in the Prezi there. And Sacred, if you do you have a link to the to that video again?
Let me see if I can find the original for you. I'll be back.
Thank you. I just closed it. Yeah, copy link. So yeah, you can see the actual simulations and stuff of it. It's a really, really good video how that played out. And I think shadow reveal, other than if you want the video for, oops, 1 second. If you want the video for shadow sets, this one right here. Oh, well, SDMP, you can see it work in reality with on the mountaintop, right? Because when you go to the peak, there's no corresponding shadow that goes upward that would have to be there, and there's no distinct shadow either. So it's already like replicatable. It's already like how it works. But like I agree, though, it would be nice to have the representation without it.
Yeah, from the peak, you're looking down at the shadow, refuting the argument that it's being cast up on the cloud, right? So it reinforces that it's perspective.
Yeah, I have a question about that. So, in that video of the jack moving away, when there was the shadow being cast across the surface of the box that was touching the peak of the triangle, there was also a corresponding shadow being cast onto the ground. Yeah, so there's a corresponding shadow on the ground and a shadow on the top surface of the box as well. Where is the shadow on the ground in the images of it happening where we claim it's because the sun is lower than the horizon relative to the surface location, but not relative to the elevated surface? Where's the corresponding ground shadow? Like there's two shadows in this image, where in the shadows being cast to the sky, there's no corresponding ground shadow.
Maybe share your screen and show that.
I can't at the moment. I'll share it with the host, though. I'll send him a link. The shadow physically leaves the ground and then is projected upwards onto the clouds. There's only one shadow. So it's not analogous to the demonstration of the triangle under the box, because there's two shadows there. One that's being translated to the surface of the top because the pyramid's physically touching the top, and then the other shadow is the shadow being cast. That's the natural shadow of the light source.
But from the mountaintop, right? The shadow never goes taller than the mountain from the top of the mountain. So it doesn't happen, right? It's just perspective.
I don't know what you're saying there.
Well, the other evidence.
Say that one more time.
The other evidence is that if you go to the top of the mountain for the same time lapse and watch the sun set and the shadow pass through the mountain, the shadow cast by the sun will never get taller than the mountain. It only goes up to the tallest part as the sun sets, and then it fades away. So it doesn't actually cast it higher than itself, which is the argument, right? It can only be cast when the sun is past the mountain, projecting it up onto the clouds. That's not the geometry that's seen from the top of the mountain.
That's what I'm saying. So from the top of the mountain, you won't see a shadow on the ground at that same time. When the shadow is being cast to the top of the cloud or being cast upwards onto the clouds, there's no corresponding shadow being cast onto the ground.
What are you talking about?
In that image there that you're looking at, right there, you look at the ground, the concrete floor, there is a shadow coming out in the shape of the triangle onto the ground. There's also a shadow being cast where the triangle's touching the surface of the overhead box. In reality, when the shadow is being cast up onto the clouds, that shadow that is on the ground in this image does not exist in the cloud shadow. The only shadow that exists is the shadow that's being cast upwards onto the clouds. So the shadow moves when the sun's at the zenith of the ground position of the mountain. The shadow is cast straight down. There is no shadow as the sun moves away. The shadow gets longer to the opposite side, with the tip of the shadow being a straight line between the light source and the top of the mountain. As that shadow gets longer and longer and longer, the shadow then disappears off the surface of the earth and is projected up onto the clouds. There's no corresponding ground shadow at that time.
Yeah, there is a corresponding shadow in the video, though. In real life, you're just in the shadow of the mountain and you can't see the sun. So there's a bunch of videos here.
Yeah.
I can look at. I'll send you the links.
So like it would happen just like this, right? The sun would go past the mountain and then you'd measure it and then you'd have this angle right here where it would never go past the top of the mountain. Here it is, right? Setting from the mountain in the time lapse. There's the measured. There's the same level, and there it is setting, right? Like right here. Never goes taller than the mountain.
Sorry, so I can't see that. Sorry, go ahead. There you go.
There you go, Shane. I put it on the big screen.
Nice. So there you go. All right. So from the mountain, there's the shadow cresting, right? And we're going to measure it. Let's do it here. All right. So from this point, it's still lower than the mountain, and the sun's way back here, right? And then here it is again, almost at the top. This is the shadow that you're seeing on the cloud from the sun way back here on this mountain, right? And then the final time right before it disappears, and there it's gone. It never gets lower than this mountain, actually, as the sun passes behind it, right? And then what you would need to see, here's what's happening, right? And then what you would need to see is this, which is what we don't see at all, right? Not seen. This is not seen. Oh, hold on.
Levi.
That's actually what you are seeing. That's what you're seeing. Go back to what's right there.
Hold on.
Alan,
Hola.
quick question. So that shadow that we see of the mountain on the clouds from the bottom from Earth, so people think that that shadow is being cast from the bottom to the cloud, but the truth is that shadow is actually on top of the clouds, and we're just looking at the shadow from under the cloud. Am I correct?
Yep, and the upward nature of it is due to perspective because when you go to the top, you see the same thing, but on the bottom, and it converges at the horizon. So, and it doesn't matter if it's sun up or sun down.
Yeah, so the mountain you're using in that picture, is that Shane?
I think so.
The reason Shane, that shadow is cut off and that sun is cut off at that point where it's cut off is because the sun is on the other side of another mountain. So you have to have a place like Mount Rainier where there's nothing but flat and out to water on the other side of it. You can't have another mountain shaving off the sun that the sun doesn't have an angle upwards. So the sun is actually setting behind a mountain to the observer's rear there that's blocking the shadow from getting to an angle that's lower than the tip of the mountain. The mountain behind that is taller or the same height or relatively close there too.
You're saying that this actually isn't the setting sun. It's not setting at all right here when it's exactly level with the object it's setting behind. You're saying that this is something else called Earth curve from a non-disclosed mountain.
Yeah. So one second.
No. So go back to your picture of the house real quick, if you don't mind. Sorry, I don't have access. So if you put another house between the sun and that. Oh, sorry. Just pause it right there if you can, if you don't mind. If you put another house between that house and the sun or the light source, the roof of the other house will cut off the sun before it gets to an upward angle across the roof of the first house that you're seeing. So you won't get an upward angle of the sun because there's another house between the light source to the left and that house. So the roof of the house to the left is acting like the horizon, which is putting it at the same elevation as the roof of that house, if you can understand what I'm saying, geometrically.
Do you have the sunset of Mount Rainier from the top so we can actually verify what you're saying?
Yeah, I do.
Yeah. All right. Switch over to Alan then.
But do you get what I'm saying? Like if there was another house there,
no,
that the sun would set
that's not what it is,
that.
but yeah.
Sure.
Yeah, okay, thanks.
We'll grant it. But here,
cool.
We can show. How do I make you not the main screen? Shrink. There we go.
Did you ask me nicely? Oh, okay, there we go.
Okay, cool. So we started with Mount Rainier actually, and we show this. He goes over different videos in the addendum over here, which I'll pull up in 1 second, and we'll go over different ones. This happens everywhere, but I'll get to the addendum here. But anyway, Mount Rainier here, and it's modeled out by an engineer who did all of this, and it shows the exact same thing that we're talking about. You literally modeled it out with 2 scale. So I'll show you the addendum now where we have
that picture looked crazy.
Other instances of it. So here's the addendum, link in the channel here. So yeah, different instances all over. You can just skip through the video here. He goes over different ones, and in particular, the belt of Venus, which is said to be that distinct bulge, but that's shown not to be true.
Again, yeah, my contention there is that there's no corresponding shadow on the ground at that point.
What? Everything looks like a shadow on the ground. Like, how would you even be able
my contention is that shadow is being projected upwards and upwards only.
Well,
Do you not see the ground as shadow?
yeah, but when you
Isn't
go,
that what I just asked about? I don't know if you were there, but I asked Alan. I said, this shadow that we're looking at right now, it looks like it's being cast from underneath onto the cloud from from below, but really what it is that the shadow is falling on top of the clouds from the top, and we're just viewing that lack of light from below, but the shadow is not falling on the underside of the cloud, it's falling on the top of the clouds. So if you were on top of that mountain, you would look at the shadow falling on the clouds below you, because the peak of the mountain is slightly above the clouds. Am I correct, Alan?
Nailed it, Lily.
No, those clouds are physically higher than that mountain.
No.
Look right there.
Yes.
Nope.
Go to the picture where there's a separation between there. Those clouds. Wait, hang on a sec. Go back to that one. Those clouds are physically higher than the peak of that mountain.
Those ones.
Otherwise, there would be a shadow connecting the peak to those clouds. If those clouds were lower than the peak and it was just the peak casting a shadow across the top side of those clouds, they would physically be connecting each other.
And when we can go
and they're not.
And when we can go to where clouds are at altitude or where the peak is higher, we can see the effect is just due to perspective solely. In addition to that, there's no sweeping shadow, there's no arc shadow that goes across the sky east to west either that corresponds. Because remember, this is a two-part argument. It's not just this shadow, it's the additional Earth curvature arc that's going to sweep across the sky. That never happens either.
Yeah, I don't contend that when the shadow is touching the top of the mountain, that's potentially the very peak poking through the clouds and being cast down. It's where there's a separation between the top of the mountain and the shadow. That shadow is being projected upwards onto the clouds. That's my contention.
Okay, that's a perspective argument.
Nice if somebody had a shot from the top of that argument.
Yeah. So what's up, Dad? What's up, Dad Bod? Did you said you had some curvature or something?
How you doing? I'm going to start by. Can I ask?
Real quick.
Go ahead.
I got about.
Just
real quick. I got to bounce, and I just wanted to thank the host for having me up. I appreciate it. Thank you so much.
No worries.
And thanks for the respectful conversation. I really enjoy having a respectful
Well, yeah,
conversation.
dude, thanks for coming and being respectful. That's really cool.
Absolutely,
man. Absolutely, man. Be safe.
You too, bro.
I apologize.
Send Baron a mic if you could.
I'm gonna see if Dad Bod can keep it going.
I'm gonna cut in really quick, Dad Bod. I'm sorry. Where do I find the carjack, rolling the carjack video?
I was trying to find it. My bad. I'm trying to find it now. Debunker.
I got you.
It's such a long time ago. Like
nope,
this argument. Oh, you got it. Okay.
Yeah.
Send it to me, Sapien, if you get it.
Good evening, Mr. Barron.
All right,
I got a bunch of invites for this. So why?
Chat. Yeah, we're here looking for mutually exclusive proof of Earth curvature. We're seeing if anyone can provide some. So we can just go over
I got about 5 of them. Which one do you want?
Oh, I mean, start with your most prominent one. What do you got?
Plumb lines.
Ooh, plumb lines. Are you you're the surveyor, lad?
Yeah, I'm a registered land surveyor in the state of Arizona.
Nice.
Alan, this is Baron. This is the guy that Taylor went to go join when she was doing her observation. He was also the one that we invited to Flat Earth Fridays when we were going over your presentation, and he said he didn't have time to stay. You remember that?
Unfortunate.
I'm a federal land surveyor from Canada.
Oh, I remember you, Dad Bod.
No, not Dad Bod. That's a different guy. Baron is the one I was talking to, but we have 2 surveyors. Baron is the one that we invited to Flat Earth Fridays. Dad Bod is another surveyor from Canada, I guess. Nice to meet you, Dad Bod. But yeah, just so you know.
Nice to meet you guys.
And I do have a question for you guys whenever y'all get a chance.
Hold on. Hey, I just jumped up in here. Alan, do you know your YouTube is not streaming?
Yeah, so when I tried to share bandwidth, it did not work out. So Shane is streaming though. I'll rip it from him later.
Shane, for sure.
Yep.
All right. Yeah.
So Baron and Dad Bod?
Give heads up.
I'm trying to get working on getting the Lake Pontchartrain Bridge plans. And do you know what I should be looking for? Is it in the as-built, the final survey, or where I should see curvature in those plans? Or do y'all know anybody who has them?
Yeah, you can just look at the horizontal control network for the lake.
Horizontal Patrol Network?
Horizontal control network for the lake.
Okay, I'm going to look that up.
Yeah, so what they had to do is they had to convert what's called a grid to ground. Do you know what that is? It's where we try to project a 3D Earth onto a two-dimensional surface. So there's a scale factor, and anything inside that scale factor is going to be less than 1, which means you have to increase the map surface to meet the ground surface. Anything outside the scale factor, you have to increase, or no, I'm sorry, it's the opposite. So everything inside the scale factor of 1, you're going to smash the Earth down. So you're going to get more distortion. Everything outside the scale factor of 1, you have to increase the map surface to meet the Earth. So you're going to have less distortion.
Repeat that name one more time. Horizontal control factor? What did you say it was?
Horizontal control network. So if you take the stations at each end of the lake, and you take the delta X, the delta Y, and the delta Z, and you turn it into a straight line distance, the straight line distance is going to be shorter. So you're going to end up having distortion in that projection.
Okay, so the horizontal control network has the build plans, you think?
No, it's what the land surveyors went out. It's the like if you pull up, I don't know, go to NOAA and look up NGS data sheets, and you'll see the difference between the geoid and the ellipsoid. So you're going to get what's called undulation.
A little intersection point between the geoid and the ellipsoid model.
Yeah, well, when you're making repeated planar measurements and you got to kind of compare the curvature, you're going to need those reference ellipsoids so that you can actually manufacture that curvature by stitching those long planar measurements together. Isn't that how it works, man?
I don't even know what you just said.
Yeah, you do. You said previously, right? You went through the discussion that if you just take planar surveying over up to say 100 miles and you stitch them together, you would need your reference ellipsoid and your reference geoid, one for the gravitational potential difference and one for the deflection of the vertical, so that you can align said models, right? That's what the deflection of the vertical is all about. That's what you just referenced, right? Both those models.
No. So do you know what plane surveying is?
They don't. They don't. They have no clue. They trust me. They have no clue.
Please don't do that.
Do that, bro. Don't do that. Yeah, don't do that. Like we don't disrespect anybody over here. Unless you really want that smoke, we get disrespectful. But you should just chill out. Let us have a conversation. If you're willing to be intellectually honest, we could do the same thing.
Right.
So here and gaslight us at all.
So what is plane?
Baron asked a question. Hold on. Please, Alan, go ahead and continue as the host to answer.
Dude, plane surveying assumes that there's no curvature, ignores it completely, right? For small areas.
Well, for up to 100 square miles. And do you know why?
Do I know why? Because, well, my answer would be because it's not necessary, and that's only arbitrary for spherical excess calculations when you string long calculations together, and only possible technically when you switch to geodesic so that you can prepare corrections to the geoidal and the ellipsoidal model, as you just pointed out.
No. So plane surveying takes place in the horizontal direction. So if you look down, you know what a plan view of a map is? It projects only the X and the Y. So if you took along the Y and you made that 10 miles, and then you went along the X and made that 10 miles, and you took and figured out what the difference between the chord and the arc was, in 10 miles, it'd be 2/100ths of a foot. So you can ignore it, but the second that you put a grade rod in the vertical direction, you can't ignore the curvature of the Earth after 1,000 feet. So that routinely shows up in the leveling process.
Right.
So if I was doing first order leveling, right? Let's say I had to do some, first order work. And so I'm using like an Invar rod, I'm using a tilt level, and I come off, some benchmark. And I use differential leveling through that process to transfer from an unknown mark or from a known elevation, which is the backside, to a known elevation, which is the foresight. And I run a series of loops to that benchmark and adjust all my nails along that line to be level, and then set up 1,000 feet away. So now I'm 5 feet above the nail, okay? And I take a grade rod and put it on that nail 1,000 feet away. I'm not going to shoot 5 feet on that rod. I'm going to shoot 502. That's the difference between the vertical and the horizontal.
So real quick,
And you're saying that doesn't
it's good
happen
to
in
see
planar?
you up here again. Baron, one question. Can you demonstrate 8 inches per mile squared over 1 mile?
Yo, don't interrupt. I am legend. Go ahead, Shane.
Yeah, I can demonstrate it.
Okay, can you demonstrate that with water?
Yes.
Please demonstrate that.
Yeah, I have videos, man, where I take a target. So I take 1 mile and I take 2 nails at each end of the lake. I set each nail at the surface elevation of the water.
He's gone.
Oh, okay.
Yeah, go ahead, Shane.
Yeah, so did you say that you need to apply differential leveling when doing planar surveying under 100 miles to account for curvature, or did you say that applies to geodetic surveying after 100 miles squared? Just so I can understand where differential leveling was required to differentiate.
So anytime, it doesn't matter if you're plane surveying or geodetic surveying. It doesn't matter. The only thing that plane surveying does is it measures the difference between distances of the arc and the chord. So if you took 10 miles and you went 10 miles away and you put a rod up and you made both nails at the same elevation, you'd have to raise that rod up 67 feet to see it through your eye level. Now, if you run along in the X and the Y, no Z, just all X and Y, then the difference, so you take LC would be 2 times the radius sine half the delta angle. So the delta angle is going to be delta over 360 is equal to your distance divided by 2 times pi times the radius. And so that's just basic geometry, right? So if you want the delta angle, well, then you just solve for the delta. I mean, you could just do distance over r and do it in radians, but
at which point do you need to convert from the chord to the arc, though, right? Because you're treating it as a planar, so meaning you're literally dealing with the flat line baseline for up to a point. And you said, well, we need to calculate, what the difference is. So when would you switch over to using the chord versus the arc?
The second that you get outside 100 square miles, right? So
literally all of planar surveying doesn't account. So literally everything you just said, as I asked before, applies only to the over 100 miles threshold and just to geodetic surveying when you're literally have to use the previously known models.
So you're missing the point, man. So whether you're geodetic, right? If you look up the definition of plane surveying and then look up the definition of leveling.
We already went through the definitions, bro.
Oh, okay. Well, I mean,
but I said you brought up differential leveling as a way to differentiate regular planar surveying with some form of curvature by using a vertical gradient with
you're trying to conflate the two.
No. I'm just summarizing so we can move to the point. Because then I asked, well, then you asked me, well, that planar surveying has to do with the arc chord relationship, and you explained how that would be and how you would calculate it. You gave us two deltas. So then what I asked was at what point during the planar survey would it switch from arc to chord? And you said only after 100 square miles, which is, of course, the differentiating factor between planar and geodetic surveying. Good so far?
Sure.
So when within planar surveying, how do we accounting for curvature, right? That was the main basis of the point.
In the vertical direction.
So then if you're not switching to the chord, so if you're not using that portion until you get up to 100 miles, then you're not literally accounting for any of it under 100 square miles. Then.
No,
is that fair?
You're counting for it under 1,000 feet if you're in the vertical direction. You're mixing up you're trying to conflate X and Y with Z.
Well, to be fair, you brought in differential leveling immediately, which is what differentiates, Y was.
Do you know what differential leveling is?
I mean,
run me through the process of differential leveling.
well, I mean, you are the surveyor, right? But you could just bring me through it, right?
So the reason why we use differential leveling is because the curvature of the earth causes an error. And when you cause errors, the way that you ignore them is you keep your distances, you keep your back sight and your foresight equidistant. Generally speaking, if I want to close something out within, 4 significant digits, then I'm usually going to keep my foresight and my back sight right around 75 feet from one another. But I can use that process, right, to make both the starting point and the end point at the same elevation. Now, if I did that, and then I set the rod on that nail and then moved away 1,000 feet, you'll see the error that the curvature of the earth causes because you're in the vertical direction.
How do you know it's wrong if you're just subtracting it from a known in the first place and then using it as the next benchmark? How do you know it's wrong? It's wrong from what?
What do you mean?
Well, you said that you're setting up backside, you're taking another reading, and then you say it's supposed to be from an unknown elevation, right? Are you saying that it's from the same
No.
elevation? Then how do you know?
You start from a known elevation, from a known point. You move from that point. The rod goes on that point. Okay? You're standing there, you're holding the rod. I take my level. I move away about 75 feet. I shoot the rod. Whatever the elevation that rod sits on gets added to what I shoot on the rod. You then take the rod, and that becomes turning point number 1. And you move 75 feet in front of me. I then turn, that becomes a foresight. Whatever I shoot on the rod now goes in the minus column. Now I jump over you 75 feet. Okay, and we do that all the way for 1,000 feet. And we get to the end where you're holding the rod on a nail that you put in the ground. Okay, I shoot the rod. That's my final minus shot. Then what I do is I kick that loop. I take the instrument and I do what's called a side shot or an intermediate foresight. I move the instrument away, like to the side, 5, 10, 15 feet, whatever, and I reshoot that nail with that rod on there. That now goes in the plus column. Every point on the way we circled in either turning point 1, turning point 2, turning point 3, whatever. All the pluses become minuses and all the minuses become pluses. When I get back to the original benchmark, if I don't zero out, then there's a bust in that loop. But if I zero out, then I now know the elevation of all those turning points. So that means if the elevation that we, want to know what it is, let's say it's, 0.2 lower than the benchmark we started on, we can now adjust that nail 0.2. Now both nails are level. Now you take the rod, you put it on there. I move away 1,000 feet to the original benchmark because they're up both at the same elevation. And I set my instrument height at 5 feet, which means I should bisect that rod at 5 feet, but I don't. Even though they're level with one another, I don't bisect that rod at 5 feet. I bisect it at 502. So if you take 1,000 feet and you divide it by 5280 and square that distance and multiply it by 0.667, that's what you get.
You're saying that's an 8 inches per mile squared error when you're doing differential leveling and treating the earth as plane.
Because in half a mile, you get 2 inches or 1,700ths of a foot.
All right, but you're taking optical measurements and you're seeing a residual and cumulative amount of bottom-up obstruction that you're then attributing at the end to a major difference from your original benchmark and saying that's how much it occurred.
I'm not talking about bottom-up obstruction. I'm talking about the process of leveling and how surveyors determine.
Well, you say shoot, right? When you say shooting the rod, what are you looking through?
I'm looking through an auto level.
Right. So an optical measurement at a rod with a leveling measurement, and you have within the horizon measurement of your site, you have like
I don't know what the horizon has to do with it, man.
Well, your midline within your site, right? You're lining that up, and you're taking a measurement off the center, right?
Yeah, you can't eyeball a grade rod.
Yeah, no, I mean, so you're looking optically, and the further out you go, the longer you look, the more is missing Therefore, the more off from the original quote
There's
level benchmark you
nothing
were.
missing. You're 1,000 feet away.
So between 1,000 feet, you're always at level then.
You should. I mean, if the Earth were flat, I should bisect the rod. Now, this gets even worse over longer distances.
Of course, the longer you look, the more spherical excess can be manufactured through the optics. That's exactly our argument.
What do you mean manufactured through optics?
Well, when you're taking measurements, say, of such precision over such distance, right? And even if you were to even introduce a known height and then use basic trigonometry to say how much of that height is missing, that also would match the proposed linear, not linear, parabolic information loss for 8 inches per mile squared. That's where you're arguing, right? That actually this error, when accumulated over a long distance, matches the amount you would force in for 8 inches per mile squared at that rate.
Okay, so let me ask you something. Let's say I adjust, right? Let's say there's I don't know, like an Air Products, right, where they produce liquid nitrogen or something like that, and they're going to go in and they're going to create this infrastructure of piping, okay? And the pipe's going to come up. It's going to come up out of the ground. They're going to have these flanged ends that they're going to bring these, machines that are going to come in. They're going to bring across from the East Coast or something. They're going to bolt right up. Let's say I adjust. Let's say my vertical datum, my basis of bearing and my basis of elevation is 2,500 feet away. And let's say that I decide to run that loop in a series of 4 turning points. Okay. And so I got to hit an order of precision to where I can get that flange to meet with whatever they bring in. Let's say I adjust for the curvature of the Earth and it's not there. What happens to the height of that flange? Is it too low or is it too high?
Wait, you guys aren't even accounting for refraction on these optical measurements, or is
No,
it
I
refraction
count.
consideration?
Yeah,
Well, how much of the error, how much of the differential from the original benchmark is accounted for with refraction versus not with refraction?
Depends on how far away you are and what the conditions are.
So if the magnitude of error over 100 meters is like 0.08 centimeters.
So can you answer my question?
Then the refraction
is the flange
would be like
too low or is it too high?
The refraction would be 0.067, which is literally almost the same. So if we're going to say that the error that we're finding is definitely, so with this optical differential that we're going to shoot, in your words, right, over this distance is actually going to be attributed not to refraction and not to, angular resolution limit, not to things disappearing and not being observed from the bottom up, but everything that we see there, and therefore every difference by the millimeter is then attributed to curvature. Is that?
I don't know. What is 0.067?
Well, that's like the combined effect of curvature or refraction, usually accounted for over 100 meters.
Okay, so you're
about.
telling me 0.067. So you're telling me 67 thousandths of a foot.
Yeah,
that's what you're saying.
But do you know what the magnitude of the error for actual curvature is? Is 0.078.
No. So it's it's about 3/4 of a foot. You're looking at about 2/3 of a foot. So 0.67. So that's 67 hundredths of a foot. You said 0.067, which is 67 thousandths of a foot.
Yeah, but
so what's the difference there between those two numbers?
Well, so 0.06 is supposed to represent the refraction, the estimated refraction error over 100 meters. 0.078 is the actual magnitude of what you're calling the measurement of curvature on the same thing.
We're talking about completely two different numbers.
Yeah, but
I'm saying 6/10. You're saying 600.
Don't interrupt. Let him finish, please.
Why would you not subtract refraction error from the curvature error first?
Because we're talking about two completely different numbers. You're talking about 600ths. I'm talking about 6/10. Do you not see a problem there? Does anybody?
I do, but I'm not seeing that you have the measurements to say that there's that much differential over this amount, because the actual normal magnitude seems to be much closer to the refraction magnitude. Very tiny, but you're arguing that the differential to prove curvature is very tiny as well.
Yeah, I'm talking about almost 7/10.
Whenever y'all are finished, I do want to ask a question, please.
You're talking about maybe 700ths, not even a tenth. So you're maybe an inch. I'm talking about over half a foot.
So but our whole position is
what?
that optical measurements over any long period of distance, right, will have an optical effect of, let's say, a linear loss of information starting from the bottom that we attribute to angular resolution that you guys specifically attribute to physical Earth curvature. And this is exactly an example of that equivalent sort of playing out. Like, sure, the longer you look, the more that you'll see. And look, that's when you can manufacture the most Earth curve out of the same measurements. But
I don't know
the
what you
optical
mean
loss.
manufacture. I'm just lost on that.
Okay, this is really important. So,
Go ahead,
Shane, let me ask him a question. So, how did we get, like, how can we verify how much refraction that there is in the atmosphere? How did we get the standard refraction numbers? And, like, what is the maximum what is, like, the maximum refraction we can see in the atmosphere?
Oh, I don't know. I don't know. But just take the building. You got a theodolite, right? You're the one with the theodolite?
Mm-hmm.
Whatever happened with that? You're supposed to show me some, I don't know, some angles or something like that you got.
We went to look for you, Baron, and you had deactivated your account.
Yeah, I actually reached out
TikTok
to you
was,
recently, but I couldn't get in touch with you.
Yeah, TikTok was getting ready to be
We
banned.
also invited you to Flat Earth Fridays, and we've been talking about it for a very long time on Twitter. So there's been a couple different times we try to reach out to you, but go ahead, Taylor.
I'm really skeptical about, like, some of the optical effects, like, because if we're using optics, like, if we're, like, seeing objects at the same time that are supposed to be hidden behind the curve, like, you know, at this same, like, pace, couldn't we just say that that proves it's flat if, like, we see things that are too short and we say that proves globe? So I just want to understand more about how the atmosphere is affecting, you know, what we're actually observing.
Then I'll tell you what to do.
Both ways.
So to get away from all that, right? To get away from all the optics and all the refraction and all the, you know, just find yourself 1,000 feet, okay, on a flat surface. Take the flattest surface you can find. Maybe when they're building an Amazon or something like that, after they pour the floor, maybe ask them if you can go in and do an experiment. And take a marker, right, and draw on the floor a little dot. And then 1,000 feet away, draw another dot. And then what I want you to do is I want you to call the first dot A and the second dot B. And I want you to pull, all right, 10 measurements from A to B and get the average. And then pull 10 measurements from B to A and get that average. Add those two averages together and divide by 2, and that's your length of the line AB, BA. Now what you're going to do is you're going to take and split that difference and put dot C in between A and B. Now, if the Earth is flat, okay, no matter how we measure on that line, point C is going to stay in line between A and B. So here's what you do. You write up this equation. You say, okay, line AC. You measure from A to C and you write down that distance. And then you measure from C to B and you write down that distance and you say, okay, line AC plus CB should equal line AB, BA. And then you pull back to close that traverse both mathematically and geometrically. Now you measure from B to C, write that down, and measure from C to A and write that down. Now what you're going to find is very interesting. You're going to find that when you measured from A to B, C was a little bit longer. And then when you measure from B back to A, C was a little bit longer. That way, you just defined the 3 legs of a vertical curve on the flattest surface that you can find. And that's only 1,000 feet. So there you go. You can just wipe away your refraction right there. Go do that. Show me what your results are, because I have mine.
Do you have them? Can you bring them to us?
Yeah, they're on my page. They're on my TikTok account.
So I was gonna ask you, like, what do you say about things that, you know, are being shown over long distances that aren't supposed to be seen? That are supposed to be behind the curve.
I don't know. I don't really see anything that can't be explained.
Like the Canigou Mountains, for example.
I don't know. Like I said, all of my observations, I generally just focus on the zenith angle.
Right.
Because the zenith angle, like for instance, my last observation was 118 miles.
Mm-hmm.
And there was 7,000 feet just missing.
Right.
It's
And
gone.
so basically, there have been observations where there's supposed to be these objects completely hidden by the curve, and we, are able to still view them. So have you ever came across, has anybody presented anything like that to you?
No. Usually what I see is, somebody's taken some picture from somebody else, and they say, well, you're not supposed to see this. And I just don't ever experience that. I've been out to the Black Swan. I've got tons of data from that.
But don't you want the Globers to use your data? So then, is it okay to use other people's data too, and pictures? And
No, I really like people to go out and do it for themselves. I think that's really where the treasure is.
I do too. I like that
You're
as
not gonna
well.
you're not gonna learn anything from me unless you. I can tell you 1,000 times, but until you go out and do it for yourself, right?
Right. I agree. So I'm just saying that there have been observations of things that are supposed to be hidden behind the curve. I don't think that most Globers don't really deny that. Do you deny that?
I like I said, I haven't seen anything that's compelling to me.
Okay. Well, I'm just saying, like, so with the optics and without hard set measurements of something tangible, like you could really go both ways with curvature, flatness, etc. So I don't know, maybe Alan, do you have anything to present like that? Like the Canada Mountains, do you happen to have those? Because that was something I just brought up to him.
No, I specifically don't argue optical equivalences because if you were to ask Barron how far too far is for an object to be on a globe, I suspect his answer would be he would have to know the height of the observer and the distance and the refraction at that time to make the prediction. So
I don't think he believes in refraction that much.
it doesn't matter if he
That's the
believes in
thing.
it or not. It's going to be
No,
applied.
it's a thing. I've got so many years of doing this. I kind of know when. I mean, we've got robotics now,
That's why I'm trying to show him this. Do you
right?
see?
Like we've got robots. Like I can just, put in the temperature inside my controller and where I am, and the robot will calculate what the refraction is for me. But generally speaking, you're just it's 1/7, right, of the curvature correction.
So real quick though, like I'm sure you're familiar with the Walter Bislin Earth curvature calculator, right? You can
I love
turn
Walter. He's a great guy. Yeah.
right. You can effectively turn any measurement into a globe observation with the refractive slider. Would you agree?
Yeah, it's just a calculator.
Right. And most people take that as like physically meaningful. So they'll argue that you actually can't falsify the globe through physical or, through optical observation. And I agree that using, the equivalence there, you can't, you're like begging the question, right? You're assuming one is more correct than the other. Because like we were saying earlier, through differential leveling and zenith angles and all this stuff, these are all optical measurements, and the deviation being perceived, could be curvature of the earth or could be an optical effect. And so we would have to reference an external way to falsify said curvature, right? Because you could differentially level things out and do all that stuff. But at the end of the day, the people that are going to build the structure there are going to level that ground. Construction workers are going to go in and level that whole site. And none of that is going to be in relation to counting a curvature or making it perpendicular to a gravitational potential model or anything like that. So I think
No, that's not true, man.
That's not true.
Yeah, I don't know
So-
what field you work in, but I've been in building trades for 30 years.
So I'll give you a quick example. There was a subway in London that was built, and what they did was, they told everyone, "Oh, Earth curvature. We have to account for Earth curvature." But when you go and read the specs for it, they said that they didn't account for curvature, and they specifically intersected the construction site with a meridian line where they said that we can just treat this as flat and linear, and to ignore all curvature corrections. So they did this project, with no curvature, and we have documentation going back to what is it, like the 1700s, where they were making like, decrees and stuff for civil engineering and whatnot, and they were saying that if you're going to do a construction site or build like a railway or a canal or any sort of road system or whatever, you have to do the whole thing with a flat baseline throughout the entirety of the project. And then we can go back to the the Grand Chinese Canal that was built before anyone realized that the Earth was curved.
So who's reading these construction documents?
You can just pull them up on Google and read them.
All right, so go ahead and pull one up and let's look at the cover page.
Wait, Baron, can you not interrupt? Because I wanted to hear the rest of what he was saying of that thought before you interrupted.
Yeah, let me see. I think I've got a stack of prints here.
Yeah, but
Actually, I do. Actually, you know what? I have a bridge here we accounted for curvature on. Let me get this.
I would like to see some evidence, though, that the reflection.
Yeah, I got it. I'll turn on my camera. We'll go through it.
Can't be playing a role in these observations.
I'm going to point out. Can I just point out something? Can I just point out something very respectfully?
Please.
Can I just point out that it's kind of ridiculous the disrespect to land surveyors there is in the chat. I mean, you trust us to build the entire infrastructures that you guys live in, road, building, and bridges. And reading these comments because we're talking about curvature and you're talking actually to a guy that knows what measurement is very disrespectful to the trade. And I'm kind of disgusted with it, actually.
Oh, well,
it's disrespectful that you came in and interrupted me just now.
Hold on 1 second. Yeah, feel free to like save that for someone who gives a shit. This isn't the place to make those kind of gripes and cry. We're having
virtue signaling is rewarded.
Yeah, if you feel that strongly about it, you're welcome to just leave.
All right, let's see here. Is this the bridge? Let me see real quick here. Which project was this? This is.
Hey, Alan, you want to drop me to the chat, please?
Sure thing.
Description.
Thank you. Keep crushing.
Later.
I don't know if they're in these documents. These ones. Well, here's all my curve data for this. Maybe they're in these documents here. There's ANC, Interstate 10.
Although I haven't heard from you, Baron, but you're really cool and really patient and mostly respectful. So thanks for coming and hanging out. Yeah. But you seem to do this a lot, right? You have these on hand to talk to flat earthers on TikTok a lot. Is that a fair statement? You have them just for us? Is that why you have a stack right now?
What do you mean?
Well, I mean, like you were like, oh, let me get my stack because it seems like something you've done before on TikTok.
No, so you do realize I'm a land surveyor, right? So I mean, here's my data collector. These are just projects that I work on. And so when you go through and you read these documents, you're going to get a cover page like this. And in that cover page, it's going to talk about, this one here, I'm not sure. Let me see. It's got the architect, the surveyor, the civil engineer. And so what they're going to give you, they're going to provide you either a rectangular coordinate system or a geodetic coordinate system. But there's a bridge that I worked on, and we had to account for the curvature of the Earth from the approach to the landing. I just got to find it.
All right. While you're doing that, what do you mean by had to account for the curvature of the Earth? Because here's the thing. I know I grew up around construction workers. I know a ton of them. Not a single one of them do anything what you're talking about. And
right.
And
they don't.
Listen, I know people that build bridges. They don't account for curvature either. And the bridges themselves, like through thermal expansion throughout the year, will expand, up to like 18 feet. So like this idea that that's just not even a real thing. They build them off center for how they do the load bearing. And I have a guy that was on a crew that worked on a canal for over 11 miles, and not a single inch of earth curvature was accounted for. So, like, while I don't disagree that you can certainly calculate things, write up cool technical specs to account for it, but in practical reality, nobody seems to be following through with that in any meaningful way.
Yeah, well, maybe I can talk with these guys. Is this it? This might be it right here. Might be out in my truck. What does it say here? Yeah, so if these guys that you're talking to, I don't know what aspect they are involved.
They're the people that lay out the foundation and everything. They go in, dig everything out,
Yeah.
level it
Yeah.
out, then pour the concrete and stuff for the
Right
baselines
on.
and
So
everything.
they're just trades guys, right?
Yeah, they're just guys that make the ground level.
Right. So here, I'll show you something. Actually, you know what? I got it right here. Here, I'll show you this real quick.
One of these is going to say that you account for curvature right on the cover page, right?
Correct.
I mean, dude, you don't even have to go that far. I'll grant it to you that it's printed in documentation. But I'm saying in practicality,
Yeah,
these lads
we'll go here. So everything now is here, right? Everything's on, electronic now. But
Sure.
if we just go here, right? So this is me. This is my project, and so I did all the work on this. So here's what I used for a horizontal datum, right? And so if you look here, the project coordinate system is based. Now this is the North American datum of 83. Right?
Literally using NAT 83, so a spherical datum. Excellent.
Hang on, wait. The North American vertical datum of 88. Now look at this. Now check this out. I'm going to show you something here. And so I would just say, just go look into this stuff and ask yourself why we don't just have one projection. Okay, so I'm in the central meridian. So I'm in zone 12. Right. Now we're using the Pima County geodetic control. And this is that control point here, right? Now this is 1.5 miles. Now look, we got scale factor. That tells you that I'm using what's called a secant projection. So if I don't use this, if I don't use this scale factor, then my project comes out wrong. Why is that if the Earth is flat?
Are you using a geodetic or projected coordinate or the local state plane as it says there?
No, if I wanted to get this into if I wanted to get it into state plane coordinates, right? So let's say I wanted to get this into state plane coordinates. Then I would need to convert it by multiplying each side of the line by this.
Oh, so that's what that factor's then for, because the other datum would already account for that though. So if you want to apply it to a Cartesian non-geodetic coordinate system such as local state plane, then you would need to apply said conversion factor for the grid. I follow you. All right.
So do that, and then tell me why I can't carry that projection to your state.
Why you can't carry? Well, every state has their own local plane coordinate system, which may or may not coincide with their place on the grid, right? And they actually may do the Mercator local transverse too. They may do their own thing. I think I used to live in Mass. They had two state plane coordinate systems for unknown reasons.
No, well, there's more than one state. So each
I don't know why. Honestly, I've always wondered if you could tell me why my state had two plane coordinate systems. Dude, I'd be
actually, your state's going to have a minimum of 3.
All right.
You're going to have a central, an east, and a west. So have you ever seen the patch on a soccer ball?
Oh, all right.
So if you take the patch off of a soccer ball, right, it's easier to pull a patch off of a soccer ball and flatten out that patch than it is to take 2 patches off of a soccer ball.
So I get you then. So that scaling factor then would just be reapplied from my local plane coordinate from that same factor. That's all that is. But that's super cool.
It's the distortion that's caused on a. Do you know what a secant projection is?
Yes, it's a type of projection with the same spherical coordinate system, which would have what? I'm not sure which of the distortions would be present.
A secant. So here, let me see if I can draw this. I'll just do it on the back of this real quick. All right. So if the Earth were flat, I wouldn't need to do this. So if I have...
You think map projections are proof of Earth shape now?
Absolutely.
Oh, okay, continue.
Yeah. So if I were to take and go like this, okay? Now you're looking at this from the side. So this is called a profile view. The only thing that you can see here is the X and the Z. The Y would be going out this way or coming towards me.
Yeah,
So
it's a type of projection with it.
this is the piece of paper, right? I took this piece of paper and I'm slicing through the earth with it.
With 2 points. Yeah.
I got one here that has a scale factor of 1, and this has a scale factor of 1. Everything outside that is greater than 1. Everything outside this is greater than 1. Everything inside this is less than 1. So if I have less than 1 and I smash this down, I'm going to get more distortion in this area than I would if I had to increase this distance to meet the map.
Yes. Yes, but so we're talking about a map projection that is inherent from the projected coordinate system of longitude and latitude. So that's the spherical part of it, right? You're arguing that this is actually the Earth, but the map that you're talking about is a projected coordinate system. When it tells you, you can either use our geodetic datum NAT83 from that with the vertical gradient, or you can use your own state plane with this scaling factor. What that's telling you is you have to adhere to the projection base that we're giving you, right? So it's based on the same datum. It's got the same geographic latitude. No matter how you need to project it, the data will be preserved, the distance will be preserved in the actual inherent coordinate system, no matter which visual scaling factor you apply to the map. Do you agree?
No.
What?
No,
Well,
it sounds like I don't know where you're getting this information, but a map projection is pretty simple, right? If I took my hand right here and I put it on this piece of paper and I traced my hand and then I turned the paper over, I could trace my hand through that paper. Do you agree?
yeah. Wait, what you said you didn't agree with what I said, but how is what I said wrong? Because I agreed with the distortion, I agreed with the secant, I agreed with the 2 points and the scale with inside and the scale outside. I agreed with the geographic datum and the state, but which part did you disagree with?
It sounds like you're trying to make it sound like it's, I don't know, manufactured or something, like it's
Hold on,
fake.
Baron, do us a favor. This is the key part to some of the conversation that I think happens often in such a polarizing topic as flat Earth and globe Earth. Can you, when he asks you, show me where I'm wrong at? He's basically saying, hey, steel man my position and then refute it. So can you steel man what he just said so that way we know that we're on the same page?
Yeah. So what he's saying is that the Earth is curved.
Y'all see what I'm saying? This is why I said, the conversation gets this off into the weeds because the globe earthers don't even understand what we're saying.
It sounds like a bunch of word salad to me, man, to be honest.
I know, Baron, bro. I feel you. I would just implore you to not use those terms because when you actually look at the definition of word salad, it doesn't apply. If you actually went back and rewound the tape, which it will be posted on YouTube, you can hear him articulate with specificity why this is not exclusive. Hold on. Why this is not exclusive evidence for a globe and how you're using conversions in order to get the predicted outcome.
I wasn't able to.
Hold on, bro. Hold on. Before you interrupt, this is the reason why. Hold on, Baron. I'm gonna give you a chance to speak. I've been quiet the whole time listening. We asked you to listen and to refute, and you couldn't even articulate his position. This is the disconnect. So if you like, maybe we could reiterate the position again, so that way you can respond directly. I think that would be more valuable.
Wow.
Y'all see what happened?
Wow, dude.
Y'all see what happened?
Oh my God. You
He agreed with
got him, bro.
But he agreed with everything I said.
Maybe he got disconnected.
Even
Maybe
my
he'll
mom
be
is
back.
laughing right now.
Hold on. Maybe his battery died. Give him a chance. Let's clown him in like 5 minutes.
She was laughing at what he said about the Earth. He said the Earth was curved. Like that's the last thing Shane would ever say.
Real quick to everybody who's saying word salad. Whenever you say word salad, it just shows that you have really pathetically inept vocabulary skills. So let that be known.
I hope he comes back.
Yeah, I'm back.
He's back.
Baron,
just give him a chance, y'all. That's what I said. Give him a chance. Don't worry, Baron. I was holding you down.
Go ahead.
Pause.
No, it sounded like you guys were like poking a little fun there.
I
said give him a chance to come back. I said give him 5 minutes, and then we'll get to clowning. But
So
we're
here's the
good.
deal. Yes, map
Real quick,
projections.
Baron.
I never got to finish. So Shane interrupted me before I was done, and then you guys started a dogpile.
Stop it, bro. We have been waiting patiently for you to go back and forth, and you actually interrupted multiple times, and we let y'all go. So
Real
if
quick
you like to
question.
continue, fine. But we're saying that you misrepresented his position. You said what he's saying is the Earth is curved.
Correct.
That is not what he's saying. So
Yeah,
we were
that's
establishing that
absolutely what he's
you
saying.
didn't understand what he was saying. So I was saying he could reiterate, or you can continue to straw man and argue against something that he didn't say. It's up to you. But we're going to reiterate our position anyway. So.
Real quick question, Baron. Were you the guy that just said word salad earlier?
Yeah, so he just threw a bunch of words together. Like, so he
Okay,
has no
so
experience with those words.
yeah, you know what? Two things you do. You interrupt, and I purposely interrupted to show you what it feels like. And the other thing is whenever you say word salad, you're basically just telling us that you have inept vocabulary skills, because nothing that he said was something that sounded like word salad to me. You know
Okay,
what
so what did he
word
say?
salad is? Word salad is when you say chicken, blanket,
Mhm.
feathers,
Yeah.
atrium, rose, gift. You
So
know,
what did
that's
he
word
say?
salad.
So
He
go
was
ahead and
making
explain to me
very
what he said.
coherent sentences, okay?
Baron, can you please stop interrupting?
I just
know,
want
like,
her to
yeah, I know,
explain to me
I know
what
you
he
want,
said.
I know what you want, but can you please stop interrupting when people are trying to have a cordial conversation? Because that doesn't seem like you're confident in your position if you have to censor. So she has been quiet as well.
not censoring anybody.
I also articulated exactly what Shane said. So we both have done it already. Now you're asking a third person in the middle of her trying to articulate something to you. So you're not really retaining any of the information. We want you to retain it so that way you can show where we're wrong. We don't want you to misrepresent what we're saying, so that way you can argue against something that we're not saying, which makes your position easier. Okay, we want you as the surveyor to show us where the logic is flawed, but you have to understand and interpret what we're saying. So
Okay.
Leliana, feel free to continue. Baron, you can respond if you want to, but we really want you to focus on what Shane says so we can get back on topic. Go ahead.
Yeah, I'm
Leliana.
going to respond. Let me know when it's my turn.
All I wanted to say was people need to just stop saying word salad, because that's not what's going on. And every time you say word salad, you're telling us you have inept vocabulary skills, and that's disgusting.
And even if Liliana didn't understand what he said, that still wouldn't mean that it had to be word salad.
Yep, just let me know when it's my turn.
Do you want Shane to articulate the position again?
No.
Do you understand what he was saying?
No.
So why would
Do
you
you
want to
just want to say your
engage?
next thing?
Yeah,
that doesn't make any sense.
So yeah, we could like let you say your next thing, and we will, but we're gonna circle back to Shane's point because it is pivotal to the conversation moving forward. Otherwise, you're gonna be talking past each other because you're
Well,
gonna.
I've got some questions for him, though. That's the thing.
Yep.
Go ahead. All right, let's start off with grid to ground, Shane. What is grid to ground?
Are you interrogating?
Were you gonna tell me, or were you gonna go through a series of questions? Because you waited a long time for you to show me how I'm wrong. What we were talking about, right, was your datum choice.
Just ask him a question, and then he's responding, trying to gain clarity, Baron. Please don't play these games, bro. You're gonna go through your whole vocabulary of every single thing relative surveying. That's just gonna waste time. You can just articulate your position, and then we can articulate ours, and then we could probably find some common ground.
Yeah,
please stop being disingenuous, please.
Yeah,
we're trying to be respectful. We're trying to show you how a real conversation is supposed to have with Flat Earth, and you're really making it difficult. So,
I want to look up grid to ground. Can someone look it up? Grid to ground? I want to know what it is.
He could just tell us.
Hey, hi. How you doing? Well, how was your night?
Good.
Hot micing, bro. Pulling up grid to ground now. Introduction to grid to ground corrections. Grid to ground corrections is drawing a mode that converts bearing and distance values to grid measurements defined by a coordinate system of your feature data. It automatically corrects bearing and distance values you enter to ground to grid aware tools. Does that sound about what you're talking about?
It's pretty close.
Okay.
So I asked Shane that, though.
Oh, sorry, I was pulling it up. Somebody asked to just pull it up, so my bad. But yeah, like he was saying though, the
Thank you
conversation.
for getting to the point, Alan. Thank you.
Yeah, it's going to take a while to do that. So if you would, just give the definition and just ask if we agree or whatever, and we could move forward from that. That would be a lot quicker.
So I have a question for Sacred. Am I allowed to proceed with that question?
Well, the point, to be clear, was on the choice of datum for the map projection. That's why we disagree. That's where I listed the things, and you went off, and then you just disconnected for whatever. That was the whole point that we're trying to get back to, right?
Yeah, yeah. So I have a real quick question for Sacred. Can I ask that question or no?
Go ahead, but we're gonna get
Feel
back
free,
to
bro. We're gonna
the
get back
Shane
on
thing.
topic though.
Okay, so Sacred, can you just sum up what Shane said for me?
Yeah, he's saying that basically we're using plane coordinate systems, and then you're using a datum and applying it to a specific coordinate system, which incorporates a spherical graticule. Basically, you're using a conversion. So when you said like, hey, you're on the front page, we can show the globe. And then when you show the front page and it says plane coordinate systems, to us, that's a problem. We're saying, why do you have to convert those things?
I just told you.
I'm not a professional at all. I just know that the basis of what you guys seem to use, y'all don't account for any curvature. And then y'all take it and you implement it into what's called an ellipsoid, which is a cooked coordinate system. And you correct whenever it doesn't apply to the things that you predict. And that's our main position. So I think that's what he was trying to articulate. I don't know what point you're trying to make with me. I think you should address Shane if you don't understand what he says. You're not going to make an example out of me, my guy. So Shane is right there. If Shane is right there, you can ask him to articulate what you don't understand, and he will do that for you. I asked you for that 3 times. So would you like him to do that?
Sure, go ahead.
Thank you. Go ahead, Shane. Proceed.
Rock on. Thank you, dude. So, like, what we were talking about is you brought up your document. You brought us to the pretext. You said, look, here's the datum. You referenced that it was a state plane coordinate system as well as an optional NED 83 geodetic datum. They offered you a scaling factor for, if you wanted to use your state plane coordinate system, you'd have to use that because that doesn't account for curvature or the spherical datum or the spherical graticule. So to do so, you'd have to use the provided scaling factor along with your secant projection, which does intersect the sphere at 2 points and has those scaling factors to the front and to the back. So what we were saying is that when you said that if the Earth was flat, you wouldn't have to do that. And what I directly refuted was that the coordinate system itself is a spherical coordinate system that doesn't actually have the ground shape to do with it. It's based on angles to the stars. Latitude is a direct measurement of Polaris, right? You have right attention and declination converting to longitude. So what you have is a spherical datum being projected into secant projections, thus having the various distortions on, say, distance, area, or size based on the sphere to the plane. But it's not because the Earth is a sphere, it's because the curve, the spherical datum is a sphere, right? So that's why you need the state plane with the correction or the sphere itself to use it, right?
Right.
Before we left.
Oh, so you agree? Because I said that last time and you said I disagree, but then I went through all the points and you agreed.
So what'd she have over there?
They had some chicken.
Hey, you're hot, Mikey.
Yo, Baron, are you paying attention or are you having a different conversation? What's going on? Because we're trying to focus here.
It was like some
You're hot, Mike and Baron.
type of thing.
Do you guys think I summed up the conversation or whatever?
Baron?
Yeah, that was a good point.
Just unmute when you're ready.
I just don't think that he's retaining any information, so we're going to be going in a circle. But Dadbot is here, so while Baron is dealing with family time, shout out to the family. Maybe Dadbot, if you'd like to respond.
Hey, what's going on? Sorry about that.
No worries, lad. So at the end there, when Shane was explaining the relationship between the coordinate systems and the datums and the positions of the stars in relation to how latitude and longitude work, you were saying that it sounded like you agreed, but you might have been talking to your wife, maybe? I'm not sure.
No, to be honest with you, man, he throws words together that I just it sounds like he's been doing some reading and he's got a lot of ideas, but not a lot of experience about those ideas.
Well, let me take a crack at it, right? Do you know how the dimensions of the ellipsoid model and the geoidal model were derived and put together?
Were derived and put together?
Yeah. Like,
No, go ahead and walk me through that.
Yeah, so it started off with celestial observations. What they did was they took a snapshot of the time of the sky at a specific day, which is the vernal equinox, right? They call it the first cusp of Aries. This is like, how they're going to walk us through the narrative of like the birth of celestial navigation and how they used latitude and longitude systems off of this reference point in the sky. So, as you know, when you traverse the land in the north, the north, Polaris, for example, will displace by 1 degree per 69 miles, right?
Mm-hmm.
So to describe that relationship, they have to come up with units of measurement, to make them come portable so that you can, establish a ground distance if you're going to start to use triangulation, right? So what they did was they took nautical miles, which is just a ratio of a circle, right, 360 degrees, and they comported that to a relation of what's called a terrestrial meridian. So they assigned an altitude to Polaris, and as they traverse the land at 69 miles per degree, and they get that deviation, they made a unit of measurement called a meter, which is 1/10 millionth of the distance of the terrestrial meridian. So that thing that displaces the the stars, right? I mean, that describes that relationship. So
Now,
for
how did
them,
they get that altitude? Do you know?
yeah, so they set it from multiplying how many latitude lines there are over, what was it, the nautical miles or whatever. You can do nautical miles or statute miles.
Yeah,
How could we
90 deg-
verify? How could we
well, no,
verify something like that?
well, you can't. You just keep calculating 90 degrees of separation based on your favorite term of measurement, 60 nautical miles or 69 statute miles per degree. Of course, based on the circumference, that's how you get that. But that's also assuming a perfectly linear relationship based on an optical measurement, right? So that's where the terrestrial
I'm
meridian
just asking,
exists.
how can you
It
make?
only exists in the coordinate system.
I'm just asking, how can you make the measurement? Like, what could you use
Oh, is
to
you just
get that measurement?
yeah, you just do elevation angles to the stars, and then you follow
Using what?
cosines using
Using
optics,
what?
anything, sextant, whatever
Okay.
you need.
Okay. So those are okay then in that situation.
Oh, they're always okay.
Oh, okay.
We're
Because
yeah.
earlier we were talking about me shooting a grade rod, and Shane here said something about optics, and you can't really trust the optics. It's manufactured to do that.
Well, no, specifically though,
So,
our argument as to why he said that isn't necessarily that the measurement is invalid. He's saying that the measurement itself and the deviation from the expected is an optical effect rather than an Earth curvature effect. So
and
that's
in what way?
the optical
So what I'm
compression will
asking,
complete
so
that.
so
So
the angle of elevation to Polaris
yeah,
can be trusted with the optics, but the measurement on the grade rod cannot be because of the optics.
well, as we
Do I have that
stated,
right?
yeah, let me break down how curved visual space works. So earlier, before you got here, we were talking about the azimuthal grid of vision, right? The how
Okay,
we
what is an
see
azimuth?
how we see in a dome. It's direction, east and west.
What is an azimuth?
It's how you see in a circle, like with the directions east
Direction
and west.
360 in a circle with true
Right,
north as the start.
right. So we see in a dome. Have you ever opened up Stellarium?
Yeah. Hmm.
Okay, so when you open up Stellarium, you see how the sky makes a dome or whatever, but they say
Hmm.
that that's actually due to Earth curvature. But there's a complete optical equivalence there, and what we see in is called curved visual space. So I gave some evidence for that earlier, how we see in a 360 with anti-crepuscular and crepuscular rays, which is the relationship where sun rays will converge and diverge around you. And then reconverge at a point behind you, so that a direct 360 degrees behind you just from natural optics. And we also see the same effect with shadows and whatnot. So this is just a natural effect of optics that we see in this curve. So we only see, from our 180 degree field of view at one time, but the effect wraps around us 360 degrees. Now, we have a radius of vision that comes along with that. So we're saying that optical effects in that of curved visual space between the near field and far field, which just means how far away something is from you. There's like a linear portion to that where the deviations from Euclidean space are not going to be different. And what I mean by that is Euclidean space would be like where an object resides in three-dimensional reality, like, where it actually is. And then your visual field would be where you perceive it. Now, there's always a slight deviation there, but when you have reference to other objects and whatnot, you can figure out the approximation or whatever, and it's not that bad. But as you get further out, you get into what's called the far field, and that has a different level of optical compression. So if you can kind of think about it like the way that you're looking out at a highway and you see the little strips of painted lines, you know how the ones that are close to you, you see them nice and long, and then as you get further, they're stretched out and compressed. So like it's that relationship there of where it goes from like a linear portion in terms of the scaling to where it becomes more extreme at the distance. That represents the distinguishment between the near field and the far field relationship. So that's best described as a logarithmic relationship, which means that there's linear portions of it where you're going to have a relationship where, you know, you would have 69 miles per degree if you were using the angles per se 25 degrees above the horizon to about 70 degrees, which is actually what's recommended for celestial navigation. So are you following so far, or do you need anything like redefined or?
Yeah. So what I need redefined is so I can use the instrument to get an elevation angle. Is that right?
Yeah.
I just want to make sure that's okay. Okay.
Yeah.
So pick your favorite mountain and give me the elevation angle on what it should be on a flat Earth. So pick any mountain, pick any distance, and tell me what the elevation angle should be on that mountain.
Well, here's the thing, right? If our radius of vision is the same as the radius of Earth, because the coordinate system that you're going to reference to confirm the radius of Earth is based off of positions of the stars, which we're saying is an optical effect rather than a ground effect, the relationship that you're going to see for optical compression is going to be the exact same. So when you see a mountain and it looks lower than what you would predict or what it matches with a radius of 3959, you wouldn't know if that's the radius of your eye or if that's the radius of...
So you're saying it's an optical illusion?
I'm saying that it's an optical effect, not an illusion. It's a real phenomenon, optical compression.
Yeah. Dynamic cause of bottom up is, not model independent.
Yeah.
So I just want to make sure I'm understanding. So the Earth measures about 8 inches per mile square, and that's an optical thing. It's not like that's not what it is. It's just like.
Well, no, at ground level specifically, you can equate what is the geometric distance to the horizon, which simplifies to something like 1.225 times the square root of the observer's height in feet, to an optical sort of ratio for the same distance to the horizon, which for a 6-foot observer using Rayleigh's criterion, an average like wavelength of light was 6 nanometers and a diameter of like 1.22 for the human pupil. And then it comes out to the same constant, 1.22 times that ratio with, 0.02 degrees. And then that would equate to 3959 from the same equivalence with tangent formula. So you have actually, the distance to the horizon for a 6-foot observer using what's called the optical diffraction limit would be 3 miles. And of course, at the same thing, square root of the 1.22 times the square root of the observer height in feet at the same thing would be at the 6 foot would be 2.9, 3 miles. So the distance to the horizon. So that's what we say at the surface level, it's equivalent.
Okay. So can you hold on, Mike? Let's just so that, because you and I aren't as smart as Shane. So let's get Shane to draw this out on paper. Let's start off with just the triangle.
Why do you gotta be so like passive aggressive, bro?
I can't follow him. I'm actually not as smart as you guys think I am. I'm one of those people that I'm very visual. Okay. And so I understand a triangle pretty well. And so what I think he just explained has to do with the triangle. So I was wondering if Shane could just bring up the triangle and we can walk through the process of what he's talking about on the different portions of the triangle.
Whoops. There you go. So you see that right there?
All right. What does he got here?
I'm going to go grab a water. You guys play nice.
Okay.
Double tap and share with your followers. Anybody you think is interested in the conversation, appreciate you guys for joining. But let's get it.
All right. So what do you got here, Shane? Walk us through it.
Well, you see an observer when you're assuming on the surface of the Earth over there to the right with, we have our 6-foot observer and we have our triangle with the angular resolution limit over there, right? Okay. And we have our theta angle and we have our 3-foot divisor, of course, which of course is one side of the triangle right over there up top. And we use our angular resolution limit, which we just went over and derived at 0.02 degrees up there. And we use our tangent over theta. We get our distance to the horizon, 3 miles at that feet, of course. We solve for our triangle, we get 3978, which is close-ish to the 3959 miles. So, of course, if the Earth's radius is said to be a circumference of 24,900, then 3963 based on the angular resolution limit. Well, it equates to the same radius. When we say there's an equivalence optically for the loss of information at the horizon based on a flat plane observation with an angular resolution limit or a sphere of radius 3959, using the Pythagorean theorem and the distance to the horizon. That's why it equates to the same 3 miles distance to the horizon, right? 3
Yeah.
miles, 3 miles.
You know
We
you
good?
can you know you can breathe. Take a breath.
Yeah, he's
Well,
all
I
right.
just want to get back to the datum that we disagreed upon from the state plane coordinate system based on the DAT 83 that you were telling us about. Because what you started with was, hey, I'm a surveyor. Look at my documents that show curvature. We never got there. We got distracted. There was no curvature that I could see. I really wanted to see those. Then we got distracted with the datums presented on your own evidence that would say that you actually have to adhere to a predefined spherical datum when doing the measurements. So then all the measurements that you took on your planar surveying, which you were arguing differential leveling under 100 square miles, which isn't where it's applied, only applied over 100 square miles. So we were trying to back that up. And what we
So
have
you're
is a
still
series
doubling
of
down
ever
on that.
well, we
You're
have a
right.
series of ever increasing backpedaling where we haven't addressed or refuted a single point, but you're still from this let's try to go back to the map projection data. Do you
I can show
agree
you.
that the
I can show you.
scaling project?
Yeah, let's go back.
Show you.
Let's actually go back to
Show you.
the plane surveying because for some reason you're still not understanding it. And so tell me the difference between plane surveying and geodetic surveying.
Plane surveying doesn't account for curvature
Can you
under
grab my
100 square
surveying book
miles,
on
right?
the shelf there, please? My 10th
Geodetic
edition.
surveying has to have previously known dimensions of the Earth to make corrections to a previously known ellipsoid model.
No.
Planar surveying has regular surveying treats the Earth as flat for up to 100 square miles.
Why?
Why are we interrogating something?
Because
like
it's
this?
easier. We already went through
We're
this, dude.
testing his understanding of the words he's using.
Shane, don't.
No, he's answering
That's wrong.
specifically. See, they used to not getting answers, so this is not comfortable. So while Shane is specifically answering his questions, he's gonna run to a point where he's gonna have to get back to the original point. What Shane is actually saying instead of trying to show that he doesn't understand the words that he's using. But that's not gonna work because Shane is really like that. So Baron, you can continue on this path, bro, but it's not gonna go where you think it's gonna go because we're not from TikTok.
I'm extremely comfortable.
We can't talk the Earth flat. All right, so here we go. This is what plane surveying is. It's that branch of surveying where in all distances and horizontal angles are assumed to be projected onto one horizontal plane. A single reference plane may be selected for a survey where the survey is of a limited extent. For the most part, this book deals with plane surveying. Now listen to this. The surveying operation of leveling takes into account the curvature of the spheroidal surface in both plane and geodetic surveying. Well, that'd be a contradiction according to Shane. Because in 1 second here, we're saying, well, wait a minute, the Earth is a plane, and we're treating it as a plane. And then in the very next sentence, you guys want me to turn my camera on so you can see it?
Well, where does differential leveling apply? Remember, we were trying to differentiate. Was it below 100 miles or above it?
I tried to, it doesn't matter. I said it's within 1,000 feet because, you all right? Yeah. What I said was one takes place in the horizontal direction and one takes place in the vertical. You're trying to treat them both as the same, and they're not. And if you want, I've got several of these textbooks you can look at. Would you like to see them?
If you could give me the name, I definitely will get them and read them.
I'll just turn my camera on. We'll read it together.
Well, yeah, and the title, please.
Yep, absolutely. So this will
We're not
be.
tackling any points at all. We're jumping around.
So here's
no, we've regressed to him showing that he's a surveyor again, which I'm totally cool with because he didn't address any of the other points, and everyone can see that.
We're in this book. It's the 10th edition. We are just in basic definitions here, just a basic definition there, and we're looking at plane surveying right here. Plane surveying is that branch of surveying where in all distances and horizontal angles, that's all we're talking about here, are assumed to be projected onto one horizontal plane. And these are to limited extent. Right here, look, right underneath it, the very next paragraph. The surveying operation of leveling takes into account the curvature of the spheroidal surface in both plane and geodetic. Because you're talking about the horizontal direction, I'm talking about the vertical direction. I just don't know how you don't understand that.
No, I understand. Now let's try to find up to how long, up to let's say up to 1,000 meters. What is the difference, the error margin that they have to account for in differential leveling under that small distance from that effect? Do you know? Do you know the average?
Of what?
Well, you're saying that they have to account for the curvature when doing plane surveying and now accounting for differential leveling. So how much is that error margin? Do you know?
Again, plane surveying is talking about horizontal angles on a horizontal plane.
But yeah,
You're
I
not in the
understand
vertical
that.
view.
I understand, but you're saying there's a difference and an error that because the
Correct.
Earth is
The
curved,
difference
how
is
much is that error? Like either what?
they're not
Like
the
what?
same. They're not the same, Shane. I don't know what. I don't know
How big is that error, right? And then how big is the proportionate error for refraction you have to take into account at the same distance? That's
Here's
all
the
I want
difference.
to.
Here's
He's
the
so well versed in math, but he just doesn't know. It's really very interesting.
Yeah. Well, we're getting to that, Mike. So in the horizontal direction.
Is Mike just the cheerleader, or did you want to
Of course he
contribute
is. Mike
something?
don't join no lives without Baron. You know that, Shane.
It's obvious. We're not going to get there.
Clear. He don't join no lives without Baron. We know that. Hey, yo, Mike, mute up, bro. Mute up, bro. Baron got this. He don't need your help. Maybe he do.
No, you're right.
Baron, you want to tag in, Mike, Baron?
Somebody
Baron,
brought
you
me
want
up.
to tag in, Mike? He
I
still
didn't
got the
have to
blue
come
box.
up.
He's still lighting
You guys
up. Maybe
brought me
Baron, you
up.
do need help. Go
You
ahead,
guys
Mike.
brought me up.
I didn't know that. I didn't know that the
okay.
professional surveyor needed help.
Yeah.
No.
Baron,
You
do
guys
you want to
brought me up.
continue or did you want to tag in, Mike?
All right. Well,
Okay, go ahead.
I just
they
tagged him
dropped him.
out. So
You
we're
tagged
good.
him out. All right, I'm gonna go, guys. That's not cool.
What?
You guys have a good night. Yeah, if you guys drop my
Need your
buddy,
cheerleader? Why, dude? We just want to
but
talk to you.
Mike's a good dude, and the thing
He didn't add anything.
We don't care about Mike.
He was
So
interrupting,
here's
and he
the
said he
thing.
didn't want to be here. I'm not going to listen to someone say, "Hey, I don't want to be here. You invited me up." Like you can
No,
just.
I
leave.
didn't hear him say that, but I got a bunch of invites to this. I'm busy. I have stuff to do. Right. I kept getting tons and tons and tons of people sending me this live.
We appreciate you
Baron,
coming on.
Yeah, we appreciate it, bro.
I got shit to do. Right.
Yeah, we
No
do
worries.
too.
No
We do
worries.
too. This is part of what we do. We have
welcome
casual
anytime, man.
conversations about the sciences, bro.
I
So we
appreciate
appreciate you coming here, and we
Baron.
appreciate
We're not
gonna
everyone
talk to you
for
as
sharing
well.
you the live to join because we really like that. So thank you.
Real quick,
Yes, I
Baron.
get it.
Baron, real quick. There's one thing I did agree with what you said.
Bounced. Well, unfortunate. Thanks for coming on, though, Baron. Much appreciated. We'll have to continue that. We'll send you some resources to follow up on, and maybe next time we go live, you can come through. And yeah, the to the mic guy, like, yeah, if you're not like, I don't know how other TikTok spaces are run or whatever, but if you're not actively contributing something to the conversation, delaying further continuing of conversation by cheerleading is completely unnecessary. So, like you said,
To be fair, Sacred's been cheerleading you guys, and nobody said nothing.
Well,
What did I cheerlead against specifically? Hold on, Alan. Hold on. What did I cheerlead specifically?
You've been playing the referee for what reason?
Yeah, because I'm a moderator. What did I cheerlead specifically is what I asked you.
Oh, my bad. Sorry, princess.
No. I hear the ad-homs and the insults. Hey, what did I cheerlead specifically? Can you substantiate your claim or no?
It's just embarrassing. I mean, at one point Baron was right. I mean, this guy, you said your argument was that Mike didn't bring anything. To be fair, nobody let him speak at one point. I've been sitting here quiet for 37 minutes or so, and Mike has been up here. He got dropped out without even having a chance to talk, and then he's being fucking argued to be, oh, you don't add nothing? Like, what is this?
Hey, Dabba, what did I cheerlead specifically? I asked you for a fourth time.
Okay, see, I got you. You want to hear? Can I go with my? It'll take fucking 2 minutes.
Also, you don't want to substantiate your claim. You want to move on after I'm giving you the opportunity to substantiate your claim against me. Now, all of a sudden, you can't articulate yourself. This has been my main problem with you guys. Not being able to articulate yourself and just saying things that are blatantly untrue. Now, if Mike wanted to contribute to the conversation, he could have definitely contributed to the conversation. But opening up your mic to say somebody doesn't understand math, when literally the surveyor told us he didn't understand the words, is not any contribution, bro. So you saying that I'm cheerleading and then not being able to substantiate your claim just shows your ineptitude as well. So you don't have to do that. If you want to move past this unsubstantiated argument, we can do that and get back to the science. Since you just embarrassed yourself, don't come at me, bro. That's not going to work. Stick to the topic, stick to the science, and you can speak. Stay cordial, stay civil, and then we can get some value out of this. Continue.
I don't mind. Get offended, stay offended. Anyways, anywho's
crying, not me.
So basically, we're gonna start by agreeing one thing about if the Earth was flat, you would all agree. I would need an answer after my question that if I am on anywhere at any height, observer, like a little bit of like in my picture, let's say 50 feet above the water, perpendicular to the water level, and I shoot a laser. So the Earth is flat. That laser is gonna hit further away at 50 feet at the same height, observer height, right? That was a question.
I'm sorry, I stopped listening, dude. Was anyone listening?
I didn't. I was trying. I didn't.
Okay.
I'm sorry, bro.
Something
Okay.
about higher. Laser's gonna hit higher and longer than 50
You're
feet. I don't
saying
know.
you're saying that if you shoot a laser horizontally over the water, and as
Yeah.
it travels over the water, then it would rise higher into elevation based off of the curve of the Earth falling beneath it, then yes, I would agree. That's what the heliocentric model would claim.
I didn't claim anything. I didn't claim anything. I asked you on a plane on a flat Earth if I drive a horizontal parallel to the water, like 90 perpendicular to the fucking ground, 90 degrees on my crosshair, and I shoot a laser on let's say 50 feet is the observer, okay, the crosshair, it would hit a 50 feet target further away because it's flat and it's horizontal. It's a question.
Oh,
I'm not.
so you're presupposing there'd be zero bottom up obstruction, and I could literally see forever in the presence of the highest amount of atmospheric opacity, ignoring
Okay,
angular
wait.
resolution and regular light attenuation. Is that really your question, homie?
Listen. You don't understand. I'm asking you. It's not about looking. I'm talking. Do you think a laser that is 50 feet is going to hit a target 50 feet away at far distance because it's flat, right?
No, because we have atmospheric refraction in both models.
Okay, so it's going to be embarrassing for you guys, but anyways,
I'll
so
take that
basically,
risk.
yeah. I know. Because let's say in my picture right here, it's 76 feet. The surveyor up there, this line is perpendicular to the water, 76 feet up. All right. And he's looking at a lighthouse, which the lighthouse, which is when the lighthouse are cool, they have data sheets with the height, circumference, all the specs about it, and the height from the water to the top and stuff, right? So how come this lighthouse, my crosshair, is way over, and I'm 76 feet observer, and the lighthouse I'm looking at is supposed to be 80 feet from water to top, and it's over the top. And so please, it's refraction brings things up or down.
Both.
Oh,
But
both. Okay.
dude,
Okay.
both depending on whatever the globularist needs it to be. I've literally heard it argued
Okay.
that it goes up and down. So like anyway,
Yeah.
the main point of contention, right?
Yeah.
In our
Yeah.
position originally,
Yeah,
right?
nearly done.
Listen,
I have to finish up. Nearly done. Yeah,
go ahead. Go ahead. Go ahead. Go
it's
ahead.
my. Yeah, thank you.
Go ahead.
So to stay flat, I'm 90 degrees. Okay, I am 90 degrees. What you don't see in that picture, there's another lighthouse further away. The one I'm looking at right now is about 9 miles from the observer, and the other one on the left is a little small thing. I'll change my picture. I'll take the other one.
Oh, my bad. Let me bring you up on the big thing. Sorry, I wasn't paying attention.
I know. I know it's gonna. It doesn't fit well, right, in the picture, and I don't know how to fit them well in for TikTok in these boxes.
No, you're good.
But
It's close
anyways, you get
enough.
the yeah. So the crosshair, it's to the top of the lighthouse. This lighthouse is about 24
Right.
miles
Right.
from. Okay, so but I needed to dip down. I am nowhere near perpendicular now. I am not level anymore. I'm pointing down to the top of a lighthouse, which is supposed to be 180 foot
Yeah.
from the water tall. But
Right on.
I'm dipping down. All right. So if I step back from my instrument right now and I look at my instrument dipping down, my how come right now I'm not perpendicular and I'm not level to the water? I'm actually looking down. Why?
Dude, this is a perfect example of remember earlier how I was talking about curved visual space, and we have two fields of three fields really. One is the near field, the far field, and the extreme far field, and how I said that they have different rates of optical compression. So the reason that you'll see the lighthouse that's closer to you taller than the lighthouse that's further away is due to that compression due to how far away it is. So the reason that it's tilted is because it's compressed. It looks like it's, under the horizon and all that. These are optical effects. And this is what this has been our position the whole time. And that's why we're looking for things that are mutually exclusive that aren't reaffirming what you would see optically on a globe or with optics with the same radius of vision.
How tall was the building on the right in that picture?
Which one?
The closest one. The closest tower.
This one here?
Yeah.
80 foot.
80 foot. And the one at the back is how many feet?
100 feet. 180 feet.
180.
No, not tall from the water. So I actually have the screenshot from all the specs from. It doesn't fit in the screen, right? It does, but okay, I could probably show a couple of them. So these are off scale. If I could zoom out a bit, refraction is in the bottom right there with the screen. Anyways, it's just an off scale. Who's breathing like hard in the mic? Okay, so this is just an off scale representation of what observation is. That it's not curved like that. It's exaggerated. We're not dumb, all right? Understand? It's an off scale. It's not to scale.
Right.
So this is what the observation is, because we know the distances from the water to the top. Each and every lighthouse have all different. I'll show all the data that are in that video. Anyways,
Listen,
that was all. That was all. That was all filmed. So that's what I'm just gonna try to. See, these one don't fit in. Damn.
You're good.
Let me
Listen,
see.
I completely agree with your assessment of the situation and how you're looking at it, right? But what we're saying is, optically, you would never know if that lighthouse or that object or whatever it is, right, is actually tilted away from you at an angle. The only possible way.
I'm showing you.
Listen, the way that you're showing a side angle of what you're showing an orthogonal view of what you would presume is happening. But remember, we're looking at it head on, and we don't know if this is due to optical compression or Earth curvature. So we have to figure out a different way to substantiate the difference there.
So you're telling me that you're not. You're telling me.
Do you know how they substantiate it, bro?
Wait. Let me finish. You're telling me that depending on my observations, you need to figure out which excuses you're going to get for it to work on flat Earth. Because I can explain what it would look like on flat Earth. I could explain to you.
Wait, Alan, can I jump in here?
We can see the building at the back.
Give me 1 second.
Yeah, it's a boat.
You can
24 miles.
See it,
24
so
miles.
Much refraction there, or
and it's on land. It's on land
distortion.
actually. It's on land actually.
Yo,
And the building on the side is the boathouse, and we have the measurements for that too in the specs. Everything is there. Everything is there. So that's what I mean. So I could tell. I'm actually pretty sure that you know what this observation would look like if the Earth was flat. But
Oh my God, exactly the same. That's the point.
Okay, yeah, listen.
No.
Stop,
You're lying
stop.
to yourself.
No, listen, stop.
You're lying to yourself.
Listen to me. When you say, I know how it would work on a flat Earth, right? Are you accounting for a radius of vision, optical compression, anything like that?
What are those things? What are you talking about?
We have
Are you an optician?
Hey, Icebroker, wait your turn, bro. We're gonna get you in just a second. We're talking to the actual surveyor. So once he finishes the back and forth, we'll go to you so we can go ahead and articulate some of these different type of definitions that you may not have heard of before. But just 1 second, Icebroker.
So listen,
if you could provide the science, like the
hold on, please don't make me mute you, bro. I just want the host to engage with the person he's talking to before you jump in. Please, thank you.
So
I just don't know why. I don't. Yeah. Sorry. Host.
Damn, bro.
Why? No. I want to talk to you. You were talking to me. Why is Shane again dropping in? Is he your? What's Shane in there?
He's showing you the same effects due to optics, and he can even show you the math to derive the distance to how far you can see to the horizon based off of your Rayleigh's criteria and diameter of your eye.
Yeah, I know. So again, I'm going to say what Baron said. I'm going to say it was okay for the stars. It's okay for the stars, but not for closer things.
So
or
listen,
it's just not okay when we show the curve.
No, it's for all of it. There's no curve to be shown. What you're
There's no
looking
curve
at,
to be shown.
please don't interrupt. What you're looking at the distance, what I was saying, right? It would look the exact same on a flat Earth because it's derived from an optical equivalence. So when you have this conception in your head that how it would work on a flat Earth, that you're going to debunk it, you're fundamentally not acknowledging the premise, and we're kind of talking past each other, and we would be using the same proofs to outproof one another. And if you'll notice, I'm not arguing that my proof is better than yours. I'm arguing an equivalence and asking if we could move on to an external way to verify actual curvature that's independent of optical measurement.
Yeah. You know why? Because I've measured flat surfaces before, and I know what it looks like. I know what perspective looks like, and I know when something is bending down. So I know that I cannot make an excuse for a perpendicular line to the shoreline, to the water line in front of me, that when it goes far away and it comes up like a triangle, like I was showing in the picture, and that for me to make up for the difference that I need to dip down for things far away, for my crosshair to dip down, to look down, and trying to I mean, it's a no-brainer. There's only one reason why I need to dip down. If it would be flat, I wouldn't have to dip down. My crosshair would actually split the 180 foot in half because it should be flat. You could try this on a table. Use your table at home, take 2 chairs, put a string from one chair to another on top of the table, let's say 6-inch high from your table, from the flat table, okay? And take a 1 foot block, pull it as far as you can on a flat surface. Tell me at what point it will fall under the rope. Just tell me.
So are you looking at Shane scroll through a myriad
this is not,
things that are analogous to what you're talking about?
Please. You just can't.
So,
you
Alan,
just can't.
And
You just can't.
I have a question. What's
No, I
optical
can
equivalence?
super easily do it, right? So you're not taking into account the observer height with bottom-up obstruction. We can demonstrate it.
Observer.
Hold on, Dad Bob. Please don't interrupt, Dad Bob. Please don't interrupt.
He's lying.
Right?
He's lying.
Hold on.
I haven't even
you
lied
can
yet,
refute
bro.
that in a second. Please don't interrupt, or we will mute you, so that way the audience can hear the articulation. I know you don't want it to come out, but we want the audience to.
Okay, he's lying.
And then after that, hold on, bro. It's not your turn to talk. Please don't force me to mute you. I don't want to do that. I want the person to respond to you directly. And also, we got Enoch up here. What up, Enoch? Shout out to the squad.
I don't
But I want Shane to finish his.
This guy stop melting?
Shane to finish his explanation. So that way we can get to optical compression and how you guys account for that.
Go sell your t-shirts, Enoch.
Why is the teacher allowed in the room?
Yo, relax, broker.
Why is the teacher in the room?
Please don't remove yourself from the panel by getting off topic.
What's an optical equivalence?
Well, we're talking about it right now, right? So when we're on a flat plane, you see this bottle on the table. Based on the observer height, if you're in the middle, the top and the bottom compression would compress at the same time. Information would be lost together equally. Equal angles compress equally, unequal angles cannot, right? So by the same metric, if we lower our observer height and repeat the experiment, then the amount of information will then come up from the bottom quicker. So this angle has become steeper, this angle has become shallower. The loss of information is now slanted towards the bottom. If we're arguing it's an optical effect, we should be able to replicate it the other way. I.e., if we're arguing bottom-up obstruction is because your eye level is close to the horizon line, then when we inverse it and we look up at a building, the same effect should occur. And in fact, when you approach a top building from the top floor, information is lost from the top first. So you have in a bottom-up obstruction, loss of information from the reversal of compression angles, literally as a function of observer height. So that's the whole argument when we say optical equivalence.
Okay.
Congratulations, you can read.
Hang on, Dad Bud. If I could respond. When I look up optical equivalence, the optical equivalence theorem in quantum optics asserts an equivalence between the expectation value of an operator in Hilbert space and the expectation value of its associated function, blah, blah, blah. That doesn't sound like what you explained.
That's associated to quantum physics, though.
Could you
He's not
cite
talking about
your
that.
source so we can look up this study on optical equivalence and what you just said?
Right. So
Because
you
I'm
can
looking
read.
and I can't find anything other than what I just read to you, but that has nothing to do with what you were talking about. So
Yeah. So what Shane just showed you is all
no, I'm
optics.
asking
Listen to
for.
me. Listen. I
Okay.
know what you're asking for, right? This is a simple definition of words. We're going to use two different words, combine them
No.
together, and talk about how the relationship would be equivalent to either the ground being curved at 8 inches per mile squared, which would
Well, you're
show.
going off topic here.
No. Listen to
Yes,
me.
he is. Yes, he is.
Okay.
I
One
mean,
second.
Can the Globers relax?
1 second,
Please.
dog. Hold on. I'm not going to be talked
we
over.
can
I'm muted
skip
in
the
my
word
own
salad and
space.
move on.
Nope. 1 second.
That's okay.
Dog. Okay, guy.
It's embarrassing.
That was easier.
So anyway, optics, right? And equivalence. Now, you guys are saying that the curvature of Earth will change the position of the star 69 miles per degree. We're saying that optically, right, there's the same relationship. So when you go to define it, that's what I'm talking about. Just because you go to Google and type it out and there's not an official term for it, doesn't
Someone else
mean
already has
it's
an optical
not.
theory, Alan. Sorry, we didn't do
Yeah,
it right.
dude. Yeah, it's just relax. And if you want to hold it to that, if you want to hinge your whole argument on that, like, congratulations, dude, you got us. Just don't waste our time and just go ahead and drop yourself down if you can't follow along.
My last. I'm gonna leave. My last question would be: why is my observation, the dip that I have, observation calculated like with actual like measurements, like fucking? Why does it match the 8 inch per eight
You're
inch per
you're
mile
begging the
square?
question there, sir. The horizon changes
Why is the
hour to
teacher
hour
in
and
here?
day
Who are
to
you?
day.
We're having a
Well,
So
conversation
can
here.
I finish speaking, icebroker?
No, go
So
sell
Nobody
the
t-shirts.
cares.
horizon
You're
Go
not
sell
involved in
changes
it.
t-shirts.
hour to hour and day to day. If you
If
guys take a time lapse,
if your
relax,
minions
bro.
can
Relax, bro.
We don't want to buy
so
t-shirts. We don't want to buy
Claiming,
t-shirts.
well, they just don't have to do live.
bro. Sorry,
We
guys.
don't want to buy
No,
t-shirts.
hey, yo, Dad Bod, we let you speak and everything. If he speaks to you and you don't want to listen, you can just leave. Like, if you're gonna make me kick you out or whatever for a badge of honor, like, that's fine. But I'm just letting you know, like, if you're gonna talk to someone and have a conversation, you have to let them speak too. You can't just interrupt them and tell them to go sell T-shirts. If you
I
don't,
said stupid. I know. I understand. Stupidity is triggering me. See ya.
all right, thank you, sir.
Yeah, that's rough. But yo, welcome, Nathan, dude. But what we were saying, what he has said was, so we can approximate it with a linear loss of information. This is a linear function. It's the same way you can approximate the curvature of a sphere with a parabolic function up to 100 miles. They are identical and undiscernible. Of course, past their differences become more pronounced. That's the actual answer to the thing he just freaked out about.
Can I share a story with you guys real quick that just happened?
Yeah, dude. Every time you come, everyone gets a rage quit or whatever.
Why do they all
Sorry,
hate
guys.
you? What did you do to them on here, dude?
Show me on
Like,
this doll where Nathan touched you, right? So this guy, Justin, his dad got me this RV spot for the whole week for free. He's just a boss. And him and I went to the hot tub tonight, and we shared Flat Earth with like 5 people. And like half of them showed up at the RV to get flyers. And you can see all of them like holding up the flyers and stuff. Dude, just good times, bro. All we do is win. And the guy there at the jacuzzi knew NASA means to deceive in Hebrew. And then the other guy, Alex, the guy on the right, he's like, I'm a pilot. I already kind of thought it was flat, but this is interesting meeting you and stuff. So good times, sir. Good to see you guys. I love all you guys. You guys are total legends.
Nice, dude. Thanks for being a flat earth celebrity and spreading the good word.
Yo, Enoch, are you still on tour?
Yeah, bro. I just finished the Tampa meetup on Sunday, and I got to go pick up my dome from Joseph Hanvey. He sent me a video of that. You can watch this on my TikTok. He set it up and everything, wanted to make sure everything was working properly. But then I got to get the RV wrapped after the dome. So good times.
Nice. Shout out to Joe Hanvey. He was just in here earlier.
Yeah, he sent me an audio message. I don't know what's going on.
I forgot to welcome him. He said like a good argument, and then I lost track of it. Yeah,
Dude, why don't they just come in here and have a civil conversation? Why do they just have to constantly like bombard the room? Like they're even interrupting each other constantly.
I'm telling you, it's different over here, bro. Like the TikTok like level of focus and just self-control, especially from the anti-flat earthers, is like literally zero. I don't understand it. I don't know why they act like that.
Well,
I mean, you
so
can
I
go
noticed
listen to 15 hours of Flat Earth Fridays, you won't get that much craziness.
Dude, I noticed when there's more of them, their confidence increases at a parabolic rate. Like, so
Oh
when there's
snap!
when there's one, they're super like they're super polite, and then when there's two, there's a little snippy, a little bit interrupting. When there's three, it's like, all right, open season, we got this, boys, let's just go, and we just shut that shit down real quick. Like, oh. Like, dude,
It's
this
just
the surveyor was fun. That was good content, but he was
yeah,
super
that's the
confident.
thing. It's like I just wish that they would not hold so much grudges based on their past experiences. Like, I get it. We've dealt with toxic anti-flat earthers too. We don't come in here just insulting everybody just because we had a bad interaction with another globe earther. So it's annoying when we try to show like, hey, we're gonna let you speak. We're gonna let your man speak, but we want you to address what we said specifically. And if you don't understand it, it's okay to say, I don't understand what you said. Please repeat it, maybe in a different way. And then we can move forward. But it's like they
Right?
hold these weird grudges, bro, and I just don't get it. It's like,
Dude,
relax.
we were having a back and forth with the surveyor, and he was like, "Yeah, but leveling," and I was like, "No, will you explain it to me?" And we gave him a long time, and he explained it. He went very slowly. I didn't interrupt. Dude, we listened the whole time, and then I asked questions about it to figure out that actually it applies over 100 square miles, and what you said in the first place isn't relevant, so we can just back right out of that. But I mean, like whenever we ask questions, we listen to the answer, and whenever they ask questions, it's try to get like a gotcha. It's a very different paradigm. It's
It
weird.
is, bro. It is. And I get it, like if you're someone on a social media platform that, everyone is spamming me to come join, like you got to show up. I get that. Like, it's somewhat of a competitive sport, but it don't got to always be a debate, bro. We could just exchange information and then we could build and then maybe we can learn something and then maybe y'all can learn something. I'm telling you, every time I learn something from a globe earther, my position from flat earth gets stronger. So I am never afraid to say, yo, I don't know what that means. I never heard about that before. Let me research that. That's okay. Like remove the ego off the table, bro. It ain't that deep.
Dude, that's polar opposite. We love to get taught new stuff. It's like, dude, like the first time we talked to Blitz, he was like, "You're confusing toroidal and poloidal." I was like, "Are we? Could be. Don't know what that word means. Let me go look it up." Right? And I was like, "Oh, differential electric field with a horizontal component to the outward toroidal. Oh, he could be right. That's a good word to learn, right?" And I was instantly like, "Thanks, Blitz. Like you've increased my vocabulary. You made me go learn a word I didn't know." And that's our attitude, I think, on most things, which is most
Imagine you
pronounced is
saying,
good.
Blitz, that's word salad.
And it turned out he was using it incorrectly. It was
Yeah,
like it's a non it's a non sequitur, but like thanks for the new word. Like that's cool.
Turns out once I read it, it didn't actually apply to what he was saying. He just threw it out to show that he knew it. But at the same time, like now we know it, so thank you.
I want to say too. He's like, "Oh, why do we always see 8 inches per mile squared?" I was on National Geographic at the Salton Sea, and in the morning it was clear as hell. You could see clear across the lake, and then at high noon it was all distorted, and it looked like 8 inches per mile squared. So we don't always see 8 inches per mile squared. And on top of that, putting something on a table and moving it away is not analogous to a boat 10 miles away on the ocean for two reasons. You've got atmospheric lensing, and you've got foreshortening. Objects in the foreground can make distant objects disappear. So there's no waves on your table. There's no miles of atmosphere in between you and the object on your table. So it's not analogous, but you can still make things disappear bottom first. Thanks for playing, Glovers.
Well said.
Thanks for playing.
Yeah, I want to look at some like bottom up obstruction. Well, I know that it exists, but it seems like it's more profound over water. But I was also gonna ask if the bottom up obstruction. I know that applies to angular
Bella, put the
size.
bag of chips down. We can't hear you.
What are you doing? Are you opening bubble wrap or what?
Got them hot Cheetos.
Okay, whatever. I thought my voice.
When you leave the app, we can't hear you either. So,
rip.
For everybody, just Taylor's back. Go ahead.
It's all good. I was just gonna ask if the optical equivalence and angular size change also applied to compression of the object and it bottom up obstruction, because I know it applies to like bottom up obstruction, but what about compression? I'm very skeptical like that the atmosphere can just cause like compression, especially at certain times of the day. But I want to learn more about that. I think it's purely optics.
It's an effect of foreshortening. There's three effects. They get smaller in the distance, they compress in the distance, and objects in the foreground can make objects in the distance disappear bottom up.
Okay, so foreshortening, they get shorter in the distance and compress?
Yeah, there's three main components, and I might be saying the same thing, compression and they get smaller, but that's one of the effects of foreshortening.
Okay, where did you learn this? Because I've been looking for it for a while.
I don't know. I don't remember where I picked it up.
Nathan just knows shit. He's been around for like 10 years or whatever.
Foreshortening.
I used to run the official Flat Earth and Globe discussion, so I've heard like all the anti-Flat Earth arguments for 10 years, and now they're like nails on the chalkboard. I just came up because I love you guys.
Dude, well, to be
Enoch,
fair,
do you have my bad? Go ahead, Shane.
so we just discovered that we actually don't know the basics. We only know the other upper level shit, so we could use some help on that. Go ahead, Sacred. Sorry.
Facts,
Yeah,
dude.
no, I was going to ask
Sometimes...
if you
go
have
ahead,
any
Sacred.
of that foreshortening stuff on your on the memory stick.
No, I got memes I could pull up real quick, but I want to say sometimes Alan and Shane are talking, and they just make me feel dumb. So I appreciate you guys.
Dude, we appreciate you too, man.
Hell yeah, man. I'm always following you, watching your stuff. I appreciate you. I've been noticing that your debates, you've been articulating arguments especially well, even if they are coming from us. I'm like, oh, dude, he's arguing ether drift in a super articulate way. That's when I started paying attention again, dude. I was like, oh, you know what? This dude's doing some good work.
I'm supposed to debate Will Duffy on the 22nd of February or the 24th, but he's like, we can only exclusively talk about my final non-experiment.
Yeah, that's all, dude. That would be a very bad idea, but he's gonna just do it anyway, so I don't know.
But the guy who gave me the RV, he's like, Nathan, you're not allowed to argue with people anymore. I don't want you offending people. I want you to just go where you're celebrated, not tolerated, and plant seeds where it's fertile ground. Don't cast your pearls before swine. And I'm telling you, I've never been happier in my life. I spent all last year arguing with anti-flat earthers, and this year, dude, it's a party in the USA.
Nice.
I feel that, man. A lot of these guys are time wasters.
I want to say this is definitely a panel worth sharing, guys. So if you guys could hold your finger on the host box, I just did it. I went from 103 to 163. Just press send. Everyone on that list. Sharing is caring. Be the change you want to see on Flat Earth. And yeah, great panel, guys.
Yes, sir.
Yo, what's up,
Just
Google?
to recap.
We're about to wrap up here.
Oh, yeah.
But yeah.
Well, I was just wanting to know where you got them articles that you were blowing them globe earthers away with, because that's some great information I'd like to read over.
Oh, dude.
Databases? Yeah,
so
databases.
If you go to adl.place, it'll take you to Shane's landing page. From that, you can click on Shane's database, and if you scroll down, you can click on Alan's database at the bottom there. And we both have published Obsidian databases, which I'll put links to in the chat as well. That's where
links don't work in the chat, Alan.
Oh,
I
no
would
snap.
advise you guys to put the link. Yeah, nothing works. They do not want you to leave TikTok. Y'all got to understand that. They want you to stay right here. But I do encourage you guys to put the links in your bios, because they will be able to go to your bios and click the link and then find your searchable content there for curve visual space, compression.
Gotcha.
Yeah, all the different types of stuff.
Shoot. Okay.
But you could show it on your screen if you want. You could big box yourself so they can see what it looked like.
Yeah, I got
Because everything, because they keep on asking, yo, what's curve visual space? You know, what's this citation? Yo, everything is on their sites, guys. Everything is there. So,
and if you go to YouTube also, and search at @space_audits, I have a playlist called Optics and Sky Curvature or something like that. It's Optics and Sky Phenomenon or something. That has everything we've ever done on optics and curved visual space and how it relates to, a perceptible reality, essentially.
Awesome.
I don't know if you guys want, I'll give you a nickel tour of the RV. I got some cool stuff in here.
Yeah, sure.
Gio, get over here.
And then we're going to close out.
Cool. Right on. Gio, let me get my dog in there. I'm walking in right now. One sec. Let me unlock it.
Yeah, you guys follow the host, man. We're going to be doing these a lot more often. I might be hosting. Shane might be hosting. Proud might be hosting. But tap in with the squad, man. Like
every Thursday.
I appreciate the info, y'all.
Yeah, we're going to establish a new standard here on TikTok. What do you think, Sacred?
Love it.
Actual factuals. That's my main frustration. It's like you guys complain about other flat earthers on here, and then when you get some people that ain't really turned up and we're trying to have a conversation, you still treat it the same way. So it's just like, come on, y'all, like, have a higher standard for yourselves, or we're going to force you to do it. That's all. Level heads in the building.
Yeah.
W's in the chat for Alan.
What is this
Oh, they was
tricked out
asking Alan if you
RV?
was a glober or a flat earth. I don't
Look
know
at
if
this
y'all
black light.
ever heard of Alan before, but that's space_audits on pretty much all platforms, I think.
Yes, sir.
All right. So we got infrared camera, P900s up here. We got the P1000 down here. I got the flashlight, the 200,000 lumen flashlight in the Fresnel lens. I need to turn some freaking lights on. Hold on. Let me turn all these on. I don't know how almost anything in this RV works.
So you just like roll into new towns with your RV full of flat Earth and like positivity, and you just start taking pictures with random flat Earthers, or you just like start talking about flat Earth and people reciprocate.
If you watch my videos, I'm meeting so many. Every day I run into a flat earther. We are everywhere. That's my new hashtag. There's the, this thing's wicked, dude. This 200,000 lumen flashlight is boss. And then we got the infrared up here, converted from Canada. I got the Follow Me drone, donated. Check these out. Flat Earth blankets. I mean, these are the softest blankets I think I've ever felt. Who is it? Alonzo does them. Flat Earth University. And I got all my conspiracy theory books up here. Well, not all of them, but a lot of them. And then we go over here. We got the Tesla coil, the Crookes radiometer, electromagnetic accelerator, sound bowl. These, you know what I want to do is I want to go to a Flat Earth meetup, and I'm going to put UN logos on Geo. He's going to be all decked out with UN logos. I'm going to get hairspray that's colored. Deck out Geo. Over here we got the Flat Earth map on the bed. And we got tinfoil hats and Flat Earth coffee over here. Bear Pelagic coffee, this stuff. This is the continuous roast, crush roast, because all we do on Flat Earth is we're continuously crushing. And this, dude, I got samples and stuff for the meetups. Like, we want to get all the products, right? And help Flat Earthers make more money. Because Flat Earthers want to support other Flat Earthers. They just don't always know where to go. And yeah, I mean, we got planispheres down here. We got my tinfoil hat collection over here. But this never ends. And I don't know, I'm just... 2025, guys, the creator really came through for me. I've been spending 8 years getting punched in the mouth and tarred and feathered off social media. And I finally feel like it was all worth it, dude. So keep up the good work. Flat Earth is always a W. Sharing is caring. Be the change you want to see on Flat Earth. I'll let you wrap it up.
Yo, appreciate you coming in and sharing the live and giving us attention, dude, because that helps. We have like no followers and no one knows we're here. So it's much appreciated.
Well, yeah, we'll get it done. You guys are going to have hundreds of people watching your live within a month. Watch. It's going to be good.
Yeah, we did pretty good today, man. Like, I had like 80, 90 people in here earlier.
Nice. Yo, before we wrap up, Shane, would you mind doing a mini rendition of Sky Miles to Meters?
So yeah, nautical mile used to mean an arc minute, which is just a ratio of a circle. The only way that it equates to any ground distance is when you say what size is the circle. The Uniform Standard of Measurements established that the size of the circle would be thus, the grand terrestrial meridian, which is the size, the length of a North Pole to the equator on the geographic gradient, literally doesn't exist. In reality, the Earth isn't curved. It's not a sphere. If the Earth isn't a sphere, a terrestrial meridian is like a concept based in math that exists only on the coordinate system, part of the gradicule. So when they went to define what the meter was in the metric system to convert into imperial, literally they decided that the ratios of all other units would be thus ratioed against the only universal metric that ties it to anything physical. In reality, is the length of a terrestrial meridian. So they literally said 69 miles per degree aspect of a sphere times 90 degrees of separation gives you 6214 statute miles, which is thus, 1/10 millionth of that equals actually 10 million meters, where 1/10 millionth of that equals 1 meter. So you have literally the nautical mile being used to define based on a ratio of a terrestrial meridian, which is why when you're using coordinate system transforms for distance, meaning when you're taking angles to the stars, things like the Havre sign and the nautical mile specifically retain the utility because their values are determined by the coordinate system themselves.
Well said.
I got two things I wanted to add real quick, guys. I'm in Florida. I reached out to Austin. I've had friends reach out to him. I said, hey, Austin, if I got to apologize for anything, I want to have water under the bridge. We have some things that happened 4 years ago, but if you guys could reach out to him and be like, Nate wants to interview you, just let him know I'm trying to get a hold of him. But also, if you guys want to sell this stuff on your website, I go to meetups and I'll sell this thumb drive for $100 all day. I've left flat Earth meetups with $500 because I sold 5 of these. But if we sell them online, we could drop the price because you don't really have to do anything. These are all videos, like the best videos I found. This is my keynote speech and NASA fakery, biblical cosmology. And then we've got books. This is where it gets crazy, right? You click on old. These are all the authors, like hundreds of authors. And then you go to like Robotham. It's not just his book. It's like everything he's ever done. So there's like 500 flat Earth books on here. Let me see what else we got. Ancient. This will have the biblical, like Apocrypha, Enoch, Jubilee, Jasher. And then you go to memes. 1,000 memes, biblical ones. Ancient cosmology are all the sky maps. So there's like 200 ancient sky maps here, maybe 250. And then you go to astrophotography. We got some films of real stars, the Georgia Guidestones, Joe Hanvey's astrophotography, star trails. I got some music and a flat Earth model that includes the stars and stuff, Komodo's flat Earth model. But if you guys want to sell these on your website, I'll split everything with you 50-50. So let me know.
Yeah, I don't have anything on there right now, but if I ever do that, I'll hit you up and we'll let Witsit know.
Yeah. I mean, I just want to get the information out there.
Yep, no worries.
So y'all be blessed, dude. Thanks for having me up.
You too, man.
Peace.
Yeah, this was fun. This was
Enoch.
Late.
Yep. All right, lads, we're going to go ahead and head off. We'll see you guys tomorrow for community Twitter space at 8 p.m. And then Sunday will be Glowbusters. Tune into that. We'll be doing a presentation on shadow sets. We'll be going more in detail on those, so tune into that to get up to date on all the latest argumentation for how sunsets do not prove that the Earth is a globe because there's no corresponding shadow sets that are specifically dictated by the geometry of a light source going below a sphere and changing that elevation angle relationship to the observer on the ground. So without that necessary component, there is no mutual exclusivity there, and it's actually in our favor. So to learn all about that, make sure to follow Globebusters on YouTube and tune into that. And then we'll be doing a presentation on Tuesday, and then we'll return to TikTok on Wednesday and Thursday again. And we'll repeat the whole cycle. We'll just keep doing it forever and ever and ever.
Keep doing it. Not going to stop.
Guys,
you gotta deal with us.
Guys, we don't stop. I don't know if you're familiar, but we started 68 weeks ago on Ether Cause. They haven't missed a week, so we'll be here.
That's what's up.
See you guys soon.
Oh, also, thank you for everyone that joined and all the people that gifted the live. We're not used to receiving real-time gifts like that, so thank you guys for that. Appreciate y'all. And see you next time.
Yeah, thank you. What does that mean? What did they do?
So some people would if they hear some fire that y'all lay down some gravy, they'll shoot you a gift so you guys can see your quote unquote score. I don't know where it is as a host. Bro, you gotta let me know, but we could see it. So Shane, if you click the 63, you can see everyone that gifted you. I can see everyone that gifted me. And I'm pretty sure you got an option too, Alan. So thank you guys for showing that love.
Yeah, thanks.
Appreciate the respectful Globers, if any, came today.
Yeah, absolutely, man. Shout out to the globularists that showed up, even though one of them got a little weird towards the end there. But shout out to the lads.
Yeah, hopefully they'll come back and they can be respectful, right?
Absolutely.
Link in bio for the replays. Let's get it.